Across the silent, immeasurable emptiness of the cosmos, light travels as a messenger, carrying stories from distant epochs and forgotten corners of the night. These stories are written in the language of physics, a consistent and elegant grammar that describes the grand dance of galaxies and the life cycles of suns. We have learned to read this language with remarkable fluency, translating the flicker of a star into a tale of predictable and understandable cosmic law. Every pulse of energy, every spectral line, every gravitational waltz seems to confirm a universe that operates on a set of unwavering principles. We find comfort in this cosmic order, a sense that the universe, for all its vastness, is ultimately knowable and rational in its deepest architecture. But what happens when a message arrives from the void that we cannot read? A story written in a dialect that seems to violate the very grammar we hold dear? Out in the deep, nestled within the constellation of Cygnus the Swan, there is a single point of light that tells just such a story. It is a star like many others, an ordinary sun in a celestial sea of billions, yet it broadcasts a signal that has confounded our finest minds. For decades, our telescopes have watched this star, patiently recording the rhythm of its light, expecting to find a familiar and steady pulse. Instead, they have recorded a behavior so bizarre, so profoundly erratic, that it stands as an anomaly against the backdrop of a well-ordered cosmos. The star does not dim in a predictable way, like a planet is passing in front of it, but erratically, with no discernible pattern or reason. Its light plummets by staggering amounts, sometimes by more than 20%, suggesting something vast and dark is periodically blocking our view. This is not the gentle dip of a transiting world. It is a profound and inexplicable plunge into an unnatural twilight, lasting for days or weeks. The laws of physics, as we have written them, struggle to account for this strange stellar heartbeat, this impossible flickering in the cosmic dark. Every conventional explanation we have put forth has been carefully considered and, one by one, has been found wanting, unable to solve the riddle. We are left staring into the abyss of our own limited understanding, confronted by a single star that questions everything we thought we knew. It is a quiet rebellion in the sky, a silent testament to the fact that the universe may be far stranger than our philosophies have ever dreamed. This is the story of that star, a journey into a deep mystery that begins with a simple observation and ends on the very edge of imagination. We begin our inquiry by acknowledging the foundation of astrophysics, that stars are, for the most part, stable and predictable spheres of incandescent gas. Their brightness may vary, but these variations follow known rules, dictated by internal processes or the orbital mechanics of companion objects. A cloud of interstellar dust, for instance, might drift between us and a star, causing a gradual and gentle dimming of its brilliant light. But the light from our mystery star does not dim gently. It drops with a sharp asymmetrical pattern that defies such a simple explanation. The shape of the light curve, the graph of its brightness over time, looks like nothing we have ever seen from a natural stellar phenomenon. It is jagged and deep, a complex series of dips within dips, suggesting not a single object, but a vast, intricate swarm of something unknown. Could it be a family of comets? A vast cloud of icy bodies that have been thrown into a chaotic orbit around their parent sun? This was one of the first and most plausible hypotheses, a fleet of fragmented worlds breaking apart and obscuring the starlight in their passing. However, the sheer number of comets required to block 22% of a star's light is astronomically large, almost beyond calculation. An event that could produce such a swarm would be so cataclysmic that it would leave behind a clear signature of glowing infrared dust. Yet, when we turned our infrared telescopes to the star, we found nothing, no telltale warmth, no glowing shroud of cosmic debris. The comets, if they were there, were cold and dark, a ghostly fleet moving without leaving the expected thermal footprints in the void. Another idea was proposed. Perhaps a catastrophic collision between two planets in that distant system shattered them into a cloud of orbiting rubble. This too would explain a vast and complex field of star-dimming material, but it suffers from the very same problem as the comet hypothesis. Such a cosmic impact would generate immense heat, painting the system in infrared light for thousands of years, a beacon we could not miss. And again, the infrared silence from that patch of sky speaks volumes, ruling out the simple violence of a planetary cataclysm as the cause. What then could be so large, so complexly shaped, and so cold as to produce the signal that we are observing from this star? Some have suggested that the star itself is not normal, that it possesses some intrinsic variability that we have not yet cataloged or understood. Perhaps its core is unstable, or its magnetic fields are twisted in such a way that they create enormous temporary star spots on its surface. But even the most extreme models of stellar activity cannot account for such a deep and prolonged dimming of its fundamental luminosity. The star's spectral type is that of a mature, F-type main sequence star, a category not known for this kind of wild and erratic behavior. It appears to be a stable, middle-aged sun, which only makes the behavior of its light all the more baffling to stellar physicists. The mystery endures because every natural explanation seems to carry a fatal flaw, a contradiction with the very data we have collected. We are forced to consider possibilities that exist on the fringes of our science, ideas once relegated to the realm of pure speculation. When all conventional doors are closed, the mind must wander into unconventional hallways, seeking an answer that fits the strange shape of the question. The data does not lie. Something enormous, complexly structured, and strangely cold is orbiting that star, eclipsing its light with clockwork irregularity. This object, or collection of objects, does not behave like a planet or a swarm of comets or a cloud of dust and gas. Its signature is unique in the annals of astronomy, a solitary beacon of strangeness in a universe we thought was becoming increasingly familiar. We are left with a profound puzzle, a cosmic cipher that invites us to reconsider the limits of what is possible in the universe. As we move deeper into the mystery, we must leave the comfortable shores of known physics and venture into the speculative waters of what might be. For it is in these moments of profound confusion that science often takes its greatest leaps forward, driven by an anomaly that refuses to be ignored. The star challenges us, not with an answer, but with a perfect question, a quiet invitation to expand our imagination to a truly cosmic scale. Having exhausted the catalog of naturalistic explanations, we find ourselves at a precipice of thought, staring into an abyss of radical possibility. The scientific method, in its elegant rigor, demands that we follow the data, even when it leads us to conclusions that feel more like fiction than fact. The light curve of this enigmatic star, officially catalogued but known to us as the Star of Whispers, is not merely unusual. It is profoundly artificial in its appearance. The sharp, asymmetrical dips, the prolonged periods of dimming, and the lack of infrared excess combine to paint a picture of something that is not gravitationally bound in a simple, chaotic cloud. Instead, it suggests a vast, complex, and solid structure, an object or series of objects moving in a controlled, albeit complex, orbital dance. This has led some of the most sober and respected minds in astronomy to cautiously, almost reluctantly, whisper a hypothesis of stunning implication: that we might be witnessing the signature of extraterrestrial technology on a scale that dwarfs our own civilization's accomplishments. This is the realm of the Dyson sphere, or, more plausibly, a Dyson swarm. Proposed by the physicist Freeman Dyson in the 1960s, this is a theoretical megastructure that an advanced civilization might build to harness the total energy output of its parent star. Rather than a solid shell, a more practical approach would be a swarm of countless orbiting solar collectors and habitats, a veritable cloud of technology enveloping the star. Such a structure would, from a great distance, appear to cause the star's light to flicker and dim in strange aperiodic ways, as different parts of the swarm transit across its face. The sheer scale is difficult to comprehend, a construction project not of a planet, but of an entire solar system, using the material of dismantled worlds to build a habitat and power source for a civilization of unimaginable scale. The Star of Whispers fits this description with an eerie and unsettling precision, presenting a candidate for what might be the first great work of cosmic engineering we have ever witnessed. The absence of waste heat, the very detail that ruled out comets and planetary collisions, becomes a central piece of this new, more exotic puzzle. A civilization capable of building a Dyson swarm would be a Type II civilization on the Kardashev scale, a master of stellar energy. Such a civilization would undoubtedly be efficient, But the laws of thermodynamics are absolute. Energy conversion is never perfect. There must be waste heat. So where is it? Some have theorized that the civilization is so advanced that it radiates its waste heat at a frequency we are not yet equipped to detect, or perhaps in a focused direction, away from us. Another, more profound idea is that the civilization is not merely collecting energy, but actively using the stellar output for computation or other processes at a quantum level, resulting in an unnaturally cold signature. The structure might not just be a power station, but a vast, star-sized computer, a matryoshka brain, whose purpose we can only guess at. The silence in the infrared spectrum might not be a contradiction, but the signature of an almost incomprehensible technological mastery. The morphology of the light dips provides further tantalizing clues. They are not uniform. Some dips are small and V-shaped, like a single large object passing by. Others are broad and complex, with smaller fluctuations inside them, as if we are seeing through a porous, intricate lattice. This variety suggests not a single, monolithic object, but a diverse ecosystem of structures. One could imagine vast, continent-sized solar collectors, smaller habitats, industrial platforms, and transport vessels, all contributing to the flickering signal. The data paints a picture of a bustling, functioning system, a metropolis on a scale we have never conceived. The transit shapes are so complex that some researchers have used them to speculate on the geometry of these hypothetical structures, suggesting fleets of triangular craft or vast, flat panels. We are like ancient humans trying to deduce the nature of a city by watching the shadows it casts upon a distant wall, unable to see the buildings themselves, but certain the shadows are not cast by clouds or birds. Let us explore the timeline of the observations, for it adds another layer of profound mystery to the Star of Whispers. Modern surveys from space telescopes like Kepler first flagged the star for its bizarre behavior in the last decade, but astronomers, intrigued by the anomaly, began to search through historical records. They painstakingly examined old photographic plates of the sky, some dating back over a century. What they found was astonishing. The star has not always behaved this way. In the late 19th and early 20th centuries, it appeared to be a normal, stable F-type star. The strange, deep dimming events seem to be a relatively recent phenomenon, appearing with increasing frequency over the last several decades. This suggests we are not looking at a static, ancient structure, but at something that is actively under construction, or perhaps has only recently moved into an orbit that makes it visible to us. We might be witnessing, in real time, the assembly of a stellar megastructure, a process that has been unfolding for the entirety of our own space age. If we are indeed observing the construction of a Dyson swarm, what could be the motivation for such a colossal undertaking? For a civilization to reach this stage, it must have long outgrown the resources of its home planet. The energy requirements for interstellar travel, for sustaining a population of trillions, or for running computations of cosmic scale, would inevitably lead to the star itself as the only viable power source. This is not an act of vanity, but of necessity for a species that has transcended its planetary cradle. The Star of Whispers might be a window into the future of any successful technological species, including, perhaps, our own, millennia from now. It represents a predictable logical endpoint for technological evolution. The fact that we have found a candidate for such a structure so early in our own search for extraterrestrial intelligence is either an incredible coincidence or a sign that the galaxy may be far more populated with advanced life than the prevailing silence would suggest. This radical hypothesis is, of course, far from proven. It remains a last resort explanation, one to be considered only when all natural possibilities have been definitively exhausted. And science continues its work, diligently searching for a more mundane solution. Perhaps there is some unknown stellar process, a new type of star whose physics we have yet to model. Perhaps the star has a strange companion, like a black hole, that is stripping its matter in an unusual way, though this would typically produce intense X-ray emissions that are not observed. Or perhaps there is a protoplanetary disk around the star that is structured in a way we've never seen before, with a severe, sharp inclination relative to our line of sight, creating these strange occultations. Each of these ideas, however, requires us to invent new, unobserved physics, making them, in their own way, as speculative as the megastructure hypothesis. The Star of Whispers forces us to choose between an unknown natural phenomenon and an unknown, but theoretically plausible, artificial one. The search for extraterrestrial intelligence, or SETI, has traditionally been a search for communication. We have listened for radio signals, for deliberate broadcasts from other technological civilizations. The Star of Whispers, however, suggests a different approach, a search for techno-signatures. These are not messages, but artifacts, observable evidence of technology's impact on its environment. A Dyson swarm is the archetypal techno-signature, a colossal feat of engineering that passively alters the light of its own star. It is a form of communication, but not an intentional one. It is simply the unavoidable byproduct of a civilization's existence and its need for energy. It suggests that instead of listening for a whisper, we should be looking for a shadow. The discovery of this star has revitalized the field, prompting astronomers to scan the data from millions of other stars, looking for similar patterns of inexplicable dimming, hunting for the shadows of giants in the cosmic dark. What would it mean for humanity if we could confirm the artificial nature of the object around the Star of Whispers? The philosophical and cultural impact would be immeasurable, a moment of contact that is both profound and terrifying. It would answer the age-old question, are we alone, with a definitive no. Yet, it would be a strange kind of contact. There is no conversation, no exchange of ideas, only the silent observational knowledge that they exist, or at least existed. The civilization responsible for this structure would be so far beyond our own in age and capability that communication might be impossible, a dialogue between a human and an ant. We would be confronted with evidence of a power so immense that it could reshape its solar system, a sobering lesson in our own cosmic insignificance. The structure would stand as a monument in the sky, a silent, eternal reminder that the universe has produced minds and technologies far greater than our own. Let us contemplate the nature of the beings who might build such a thing. They would be a species that has overcome the existential threats that we currently face: war, resource scarcity, planetary catastrophe. They would be masters of collaboration on a scale of billions or trillions of individuals, working towards a singular goal over millennia. Their science would be a complete theory of physics, their engineering a mastery over matter and energy. But would they still be biological? A civilization this ancient may have long since transcended the fragile limitations of flesh and blood, uploading their consciousness into a computational substrate. The Dyson swarm might not be a habitat for bodies, but the very body of a godlike machine intelligence. The Star of Whispers might not be hiding a civilization. It might be the civilization. We are not just looking at their house, we may be looking at them. A thinking, living entity the size of a solar system. The great dimming events, where the star's light drops by over 20%, are the most dramatic features of the light curve. Let's analyze what this physically implies. For an object to block that much light from a star, it must be truly enormous. For comparison, the transit of a Jupiter-sized planet, the largest in our solar system, would only dim our sun's light by about 1%. Therefore, the object or swarm of objects orbiting the Star of Whispers must have a collective surface area thousands of times greater than that of Jupiter. If we are talking about solid, opaque objects, this is a staggering amount of material. It has been calculated that dismantling all the planets in a typical solar system might provide just enough mass to construct such a swarm. This implies an industrial process of almost unimaginable scale and efficiency, a civilization that literally consumes its own planetary system to fuel its continued existence and growth, a final, irreversible step in its technological evolution. Another key feature is the asymmetry of the major dips in the light curve. A solid, spherical object like a planet passing in front of a star produces a very symmetrical, U-shaped dip. The light fades, stays low, and then returns to normal along a predictable curve. The dips from the Star of Whispers are often highly asymmetrical, with a sharp, rapid ingress followed by a slower, more gradual egress. This is the signature of an object with a leading edge and a trailing tail, much like a comet. However, as we have established, the comet hypothesis fails due to the lack of infrared heat. So what could a vast, cold, artificial object with a comet-like shape be? One speculative design for a, quote, starlifter, a machine for mining material directly from a star, involves powerful magnetic fields that would channel stellar plasma, creating a trailing plume that could cause exactly this kind of asymmetrical light signature. We might not just be seeing a power station, but a mining operation of stellar proportions. The aperiodic nature of the dimming events is also a crucial piece of the puzzle. If we were observing planets, even a complex system of them, their orbits would eventually reveal a pattern, a predictable rhythm. The dimming events at the Star of Whispers, however, appear to be chaotic, with no discernible long-term periodicity. This doesn't necessarily rule out an artificial origin. In fact, it might support it. A natural system is bound by the simple laws of gravity. An artificial system, a swarm of independently maneuvering habitats and collectors, would not be. The orbits could be actively managed and changed to suit the needs of the civilization, making the overall pattern of transits appear random to an outside observer. The lack of a pattern could, paradoxically, be the pattern we are looking for, the signature of deliberate, intelligent control, rather than the clockwork mechanics of a natural celestial dance. To deepen the mystery, further observations have revealed that the star isn't just dimming in the long term, but its overall brightness has been steadily decreasing over the century of data we have on record. This is a separate phenomenon from the short-term, rapid dips. It's a slow, steady fade, as if a veil is gradually being drawn across the star. This could be interpreted as the ongoing expansion of the Dyson swarm, with more and more collectors being added to the system, progressively blocking more light over the decades. This observation aligns perfectly with the idea that we are witnessing a construction project in medias res. The star is slowly disappearing from our sky, being bricked up by an unseen, industrious intelligence. In a few thousand or 100,000 years, it might vanish from the visible spectrum entirely, leaving behind only a faint, cool glow in the infrared, the tombstone of a star that has been completely encased and consumed. The implications of the Star of Whispers extend to the famous Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for it. If advanced civilizations build Dyson swarms, they might become very difficult to detect. They would no longer broadcast radio signals into space, as all their communication would be internal to the swarm. They would no longer be visible as bright, shining stars. They would, in effect, disappear. Perhaps the reason the universe appears so quiet and empty is because the most advanced civilizations are hidden behind these self-imposed shrouds, silently harnessing their star's energy in a state of cosmic isolation. The Star of Whispers might be a rare exception, a civilization we caught in the act of disappearing, before the final brick was laid. It could be that the galaxy is filled with these dark civilizations, and we have only just now figured out how to see their shadows. Let us reconsider the material science involved. Building structures that can withstand the intense radiation and gravitational forces so close to a star would require materials with properties far beyond anything we can currently create. They would need to be incredibly strong, lightweight, and capable of operating at extreme temperatures. Perhaps they are woven from carbon nanotubes or graphene on a planetary scale, or perhaps they utilize some form of exotic matter stabilized by force fields we can only dream of. The engineering challenges are so immense that they underscore the sheer gap in knowledge and capability between our civilization and the hypothetical builders. They would not just be masters of astrophysics, but of materials science to a degree that would seem like magic to us. The structure itself is a testament to a complete understanding of the fundamental forces of nature, an ability to manipulate matter at the atomic level with perfect precision and on a colossal scale. An alternative and slightly more unsettling speculation is that the structure is not a habitat or a power station, but a weapon, a star killer, or a stellar containment system. Perhaps two hyper-advanced civilizations are at war, and the structure is a form of shield or siege engine. Or perhaps the star itself is unstable, destined to go supernova, and the structure is a colossal containment device built to protect the surrounding space from the cataclysm. This would explain the need for such a massive and robust construction. However, this line of reasoning is pure speculation, as there is no evidence to suggest a conflict or a stellar instability. The principle of Occam's razor, which favors the simplest explanation, would still lean towards the energy harvesting model, as it is a predictable, logical outcome of technological growth. Yet, the universe has no obligation to be simple, and the shadows around this star could be hiding a drama far more complex and violent than we can imagine. The continuing observation of the Star of Whispers is one of the most compelling projects in modern astronomy. Teams around the world are dedicating telescope time, from ground-based observatories to space-based assets like the Hubble and James Webb Space Telescopes, to stare at this single point of light. They are searching for any clue that could crack the case. The key goal is to catch a dimming event in real time and analyze the light that filters through the obscuring object. The spectrum of that filtered light could reveal the chemical composition of the object, telling us if it is made of rock and ice, as a comet would be, or of processed metals and complex molecules, as an artificial structure might be. Such a discovery would be the smoking gun, the piece of evidence that could transform the hypothesis from fascinating speculation into a revolutionary discovery. Until then, we can only watch and wait and wonder. Imagine the perspective of the builders. To them, we are utterly insignificant. Our entire planet would be a microscopic speck from their vantage point. Our civilization, a fleeting spark in the cosmic timeline. They are likely unaware of our existence, and even if they were, they might not care. Their concerns, their goals, their very thoughts would be on a level so far removed from ours as to be mutually incomprehensible. When we look at the Star of Whispers, we are perhaps like bacteria in a petri dish, observing the shadow of the scientist looking down through the microscope. We can register the shadow, we can note its strangeness, but we can never comprehend the nature of the being that casts it. This is a humbling and profoundly lonely thought, to be in the presence of greatness, but to be so fundamentally out of its league that the only possible relationship is one of silent, distant observation. The star's very name in our catalogs is KIC 8,462,852, a dry, technical designation for what may be the most extraordinary object we have ever found. This contrast is a beautiful metaphor for science itself, the dispassionate collection of data that, when assembled, can reveal a truth more poetic and awe-inspiring than any myth. The star has been given informal names, like Tabby's star, after the lead astronomer who studied it, or the WTF star for its baffling behavior. But I prefer the Star of Whispers because it does not shout its presence with radio signals. It merely whispers a secret to those patient enough to listen to its light, a secret about the potential for life and intelligence to reshape the cosmos on the grandest of scales. It is a subtle hint that the universe is not a dead collection of rocks and gas, but a canvas upon which consciousness can paint masterpieces of engineering and ambition. Let's reconsider the possibility of a natural explanation, but one that is simply new to us. One theory posits a sub-brown dwarf companion in a highly eccentric 750-year orbit. This object would be larger than a planet, but too small to ignite nuclear fusion. As it makes its closest approach to the star, it could be surrounded by a vast swarm of Trojan asteroids or comets, trapped in its gravitational Lagrange points. This swarm could be what is causing the complex dimming events. The problem is that such a configuration has never been observed and is difficult to model. Furthermore, the long-term, century-scale dimming remains unexplained by this model. It requires us to believe in a unique and unprecedented type of solar system architecture. In a way, this explanation is just as exotic as the megastructure hypothesis, replacing the mystery of an alien intelligence with the mystery of an entirely new class of celestial mechanics. The psychological effect of this mystery on the scientific community is palpable. It has fostered a sense of humility and wonder. In an age where we have mapped the cosmic microwave background and detected gravitational waves, where we feel we are converging on a theory of everything, the Star of Whispers serves as a vital reminder that we have barely scratched the surface. It tells us that there are still fundamental discoveries to be made, not just at the quantum or cosmological scale, but in our own galactic backyard. It has reinvigorated the spirit of exploration, the idea that simply by looking up at the sky with new eyes and new tools, we can find something that challenges our entire worldview. It is the perfect scientific mystery, a well-defined problem with a wealth of high-quality data that points to no easy solution, forcing us to be more creative, more rigorous, and more open-minded. The search has now expanded. Astronomers are running algorithms over the massive datasets from missions like Kepler and TESS, transiting exoplanet survey satellite, which have monitored hundreds of thousands of stars. They are specifically hunting for other instances of large, aperiodic dimming. So far, the Star of Whispers remains unique. A few other candidates have been flagged, with strange light curves that are not easily explained, but none exhibit the same extreme depth and complexity of dimming. This uniqueness is itself a clue. If Dyson swarms were a common outcome for advanced civilizations, we might expect to see more of them. Its rarity could mean that such structures are indeed rare, or that we are looking at the wrong time, or that the specific geometry of this system makes it uniquely visible to us. Or it could mean that the natural explanation, whatever it may be, is a 1 in a billion celestial fluke. Let's entertain a darker, more philosophical interpretation of the Dyson swarm. It represents the ultimate form of cosmic introversion, a civilization that encases its star is cutting itself off from the rest of the universe. It is no longer sending or receiving light from the broader cosmos. It creates a private, artificial universe for itself, powered by its own sun. This could be a defensive measure, a way to hide from potentially hostile cosmic neighbors, a concept known as the dark forest hypothesis from science fiction. In this view, the universe is a dangerous place, and the smart thing for any civilization to do is to stay quiet and hidden. Announcing your presence with radio signals is a fatal mistake. Building a Dyson swarm is the ultimate act of hiding in plain sight, by disappearing. The Star of Whispers in this light is not a monument to ambition, but a fortress born of cosmic fear. The Star of Whispers is approximately 470 light-years away from Earth. This immense distance means we are seeing the star as it was in the 6th century AD, around the time of the fall of the Western Roman Empire. The light that is currently entering our telescopes left its source when our world was a vastly different place. Whatever process is causing the dimming, be it natural or artificial, has had another 1.5 millennia to unfold. If it is a construction project, it may be significantly more complete by now. If it is a natural phenomenon, it may have evolved or dissipated. We are watching a historical recording, a ghost of light. The true present state of the star is forever hidden from us, a reality that will only be revealed to our distant descendants 470 years from now. This temporal gulf adds another layer of profound mystery and detachment to our observations. Could the structure be something other than a power station or a habitat? One fringe idea suggests it could be a stellar engine, a Skadov thruster. This is a theoretical megastructure that would consist of a massive solar sail, a statite, positioned on one side of the star. The radiation pressure from the star would push against the sail, and the gravitational attraction between the star and the sail would effectively turn the entire star system into a giant, steerable rocket. A civilization could use this to move its entire solar system through the galaxy, perhaps to escape a future catastrophe like a nearby supernova, or to explore new regions of space over millions of years. This would not cause the same kind of deep dimming as a full swarm, but a sufficiently large and complex thruster could potentially account for some of the observed light dips. It's an even more ambitious concept than a Dyson swarm, not just harnessing a star, but driving it. The study of exoplanets has taught us that solar systems are incredibly diverse, filled with hot Jupiters, super-Earths, and other planetary configurations we never imagined. It's possible that the explanation for the Star of Whispers lies in a type of planetary system architecture that is simply unknown to us. Imagine a star surrounded by a massive, dense ring system, not of small particles like Saturn's rings, but of planetesimal-sized objects. And imagine this ring is being disturbed by a large, eccentric planet, causing vast, clumpy waves of material to periodically pass in front of the star. This clumpy ring model could potentially explain the deep, asymmetrical dips without invoking alien intelligence. However, creating a stable system with this specific architecture is incredibly difficult, and it still struggles to explain the long-term, century-scale fading. It remains a possibility, a testament to the fact that nature's imagination may yet be greater than our own. The information we have gathered from the Star of Whispers is, in its essence, a shadow play. We see the darkness, but not the object casting the shadow. This is a fundamental limit of the transit method. To truly understand what is there, we would need to resolve it directly, to take a picture of it. With our current technology, this is impossible. The star is too far away, and the objects, however large, would be too small to be imaged directly by any telescope we can build on Earth or in space. It would require an interferometer with a baseline hundreds of kilometers wide. However, future technologies, perhaps fleets of telescopes flying in precise formation, could one day achieve this. It's a goal for the distant future, but one day, we might be able to move beyond the shadows and see the puppeteer, revealing either a wonder of celestial mechanics or the greatest engineering project in the known universe. Ultimately, the Star of Whispers holds a mirror up to our own civilization. It forces us to confront our own technological infancy and our own potential future. The questions it raises are as much about us as they are about a distant star. What is the ultimate destiny of a technological species? Is it to expand and consume, to harness the power of stars? Or is it to find a way to live sustainably within the limits of a single planet? Do we eventually transcend our biological forms? Do we become explorers, builders, or hermits? The Star of Whispers presents one possible, tangible answer to these questions. It is a vision of a potential future, written in the language of light and shadow, broadcast across the void. Whether we find it inspiring or terrifying says more about our own hopes and fears for humanity's journey into the great, silent night. The mystery continues. The star remains a focal point of observation and a wellspring of speculation. It represents a perfect nexus of data and imagination, a place where the rigorous discipline of astrophysics meets the boundless frontier of philosophical inquiry. We do not know what is causing the light of this distant sun to flicker and fade. It could be a natural phenomenon so rare that we have never seen it before. Or it could be the shadow of another mind, vast, ancient, and utterly alien. For now, the only certainty is the mystery itself. The Star of Whispers hangs in the night sky, a cosmic question mark, inviting us to look deeper, to think bigger, and to embrace the profound and beautiful uncertainty that lies at the heart of our quest to understand the universe. The story is not over. In many ways, it has just begun. To appreciate the scale of the anomaly, we must ground ourselves in the principles of stellar photometry, the science of measuring the brightness of stars. For millennia, this was done with the naked eye, but today we use incredibly sensitive electronic detectors called CCDs, which can measure changes in brightness as small as 1 part in a million. It was this precision that allowed the Kepler Space Telescope to discover thousands of exoplanets. The instrument was designed to detect the minuscule periodic dips caused by worlds crossing their suns. When Kepler's automated algorithms analyzed the data from KIC 8,462,852, they were repeatedly stumped. The dips were too deep, too irregularly shaped, and too aperiodic to fit the profile of a planet or even a binary star system. The data was so unusual that it was initially flagged as a potential instrument error, a glitch in the hardware. Only after rigorous verification was it confirmed that the star itself, not our telescope, was the source of this bizarre and unprecedented signal. Let us explore the energy budget of the system. An F-type main-sequence star like the Star of Whispers is significantly larger, hotter, and more luminous than our own sun. Its total energy output is several times greater. For a civilization to undertake the construction of a Dyson swarm, the energy cost of the project itself would be astronomical. The energy required to dismantle a planet, move its mass into a suitable orbit, and process it into building materials would be immense. It's a classic chicken and egg problem. You need vast amounts of energy to build a structure that is designed to collect vast amounts of energy. This implies that the civilization must have already mastered another large-scale energy source, perhaps industrial-scale nuclear fusion, before even beginning the stellar project. The Dyson swarm is not the beginning of their journey into energy mastery, but its ultimate culmination, the final step in a long technological ladder that began perhaps with fire and stone tools on a long-forgotten home world. The historical light curve data, rescued from old photographic plates, is a crucial element that broadens the mystery from a mere snapshot to a century-long film. This practice, known as stellar archaeology, is a painstaking process. Astronomers must find archived plates from observatories around the world, digitize them, and carefully calibrate the brightness measurements of the star relative to its stable neighbors in the same field of view. The analysis, led by astronomer Bradley Schaefer, suggested a slow secular dimming of about 20% over 100 years. This result, however, has been subject to intense debate, with other researchers suggesting the fading could be an artifact of using different telescopes and emulsions over the decades. While the short-term deep dips are undisputed, this century-long fade remains a controversial but tantalizing piece of the puzzle. If true, it would almost single-handedly rule out most natural explanations and point overwhelmingly towards a massive, ongoing construction project. Consider the possibility of a post-biological civilization. If the builders have shed their organic forms for digital existence, their priorities would be fundamentally different from ours. Their primary needs would be matter for computational hardware and energy to run it. A Dyson swarm configured as a Matryoshka brain, a series of concentric spheres that capture and use stellar energy for computation, becomes an entirely logical endpoint. The outermost layers would operate at very low temperatures, radiating away waste heat at long infrared wavelengths that would be difficult to detect. Such a civilization might not be interested in expansion or communication. Its goal could be entirely internal: to simulate universes, to explore the vast landscapes of mathematics, or to experience eons of existence in subjective virtual realities. They would be cosmic introverts by choice, their entire universe contained within a shell around their star, silently thinking in the dark. The flickering of their star would be the only hint of the boundless intellectual life contained within. The failure of the protoplanetary disk theory deserves a closer look. Young stars are often surrounded by massive disks of gas and dust, the raw material from which planets form. In some cases, if we view this disk edge-on, clumps of material could theoretically pass in front of the star and cause dimming. This was an early and attractive natural explanation. The problem is that the Star of Whispers is not a young star. Based on its spectral type and other characteristics, it is a mature, middle-aged star, several billion years old. By this age, the primordial disk of gas and dust should have long since either coalesced into planets or been blown away by the star's solar wind. To have such a massive, clumpy disk around a star of this age is, in itself, an unprecedented anomaly. It would require some recent, cataclysmic event, like the shredding of a planet, to have generated a new, late-stage debris disk. Which brings us back to the problem of the missing infrared heat signature. The search for deliberate signals from the system has, so far, yielded nothing. SETI projects, including the Breakthrough Listen initiative, have trained powerful radio telescopes on the star, listening across a broad range of frequencies for any sign of artificial narrowband transmissions. They have searched for the kind of beacon we imagine a friendly civilization might send. The result has been a profound and unbroken silence. This silence is often used as an argument against the megastructure hypothesis. If a civilization is advanced enough to build a Dyson swarm, surely they would have advanced radio technology. But this is an anthropocentric assumption. They may use communication technologies we cannot comprehend, like modulated neutrinos or gravitational waves. Or more simply, they may have no reason to broadcast. Their communications could be entirely local and focused, or, as discussed, they might be deliberately choosing to remain silent in a dark forest of a galaxy. The absence of a radio shout does not negate the presence of a vast, silent shadow. Let's consider the light itself. The dimming is not uniform across all wavelengths. Observations have shown that blue light is blocked more effectively than red light during the dips. This is a significant clue. Small particles like interstellar dust are very effective at scattering shorter blue wavelengths of light. It's the same reason our sky is blue. Larger opaque objects, however, should block all wavelengths of light equally. The fact that blue light is dimmed more suggests that whatever is causing the blockage is not made of large, solid objects alone, but contains a significant amount of fine dust. This has been used to revive the comet hypothesis, suggesting a comet-like tail of dusty debris. However, for the alien megastructure theory, this simply adds a design detail. Perhaps the structures are not perfectly solid, but are accompanied by a cloud of industrial effluvia, or maybe they are designed with a porous dust shield for micrometeorite protection. The data point doesn't solve the mystery, it just makes the shadow more complex. The existence of the Star of Whispers forces a profound reevaluation of cosmic loneliness. For centuries, we have looked out into a seemingly sterile cosmos. The silence has been so deafening that it has shaped our philosophy, our religion, and our sense of place. We have defined ourselves as the sole bearers of consciousness in a vast, unthinking void. If this star is what it appears to be, then that entire worldview collapses. It means that mind is not a bizarre exception on a single blue planet, but is a cosmic force capable of reorganizing matter on stellar scales. It would mean that we are not alone in our ambition, our curiosity, or our drive to survive and grow. We would still be rare, perhaps, but not unique. We would be part of a larger story, a galactic narrative of life's struggle to carve a niche for itself against the entropy of the universe. The silence we hear might not be an absence of life, but simply the sound of other minds quietly at work. The stability of the star system is another factor to consider. Introducing a massive artificial structure into a solar system would have significant gravitational consequences. The orbits of any remaining planets would be perturbed. The stability of the swarm itself would need to be actively managed to prevent collisions and orbital decay. This would require an immense and continuous expenditure of energy and a level of computational foresight that is, again, almost beyond our comprehension. The system would be a masterpiece of celestial engineering and active traffic control. The fact that the structure has not, as far as we can tell, crashed into the star or flown apart into interstellar space is, in itself, evidence of the incredible technological sophistication that would be required to build and maintain it. It is not a passive structure, but a dynamic, living system that must be constantly tended to by its creators or their automated systems. What if the structures are not from a living civilization, but are the ruins of a dead one? We could be witnessing the slow, graceful decay of a billion-year-old masterpiece. The civilization that built it may be long extinct, victims of their own success, a cosmic war, or simply the slow march of time. The swarm might now be a ghost fleet, its automated systems slowly failing, its orbits degrading, causing components to collide and break apart, creating the clouds of dust that cause the strange light variations. In this scenario, we are not witnessing a construction, but a demolition. We are cosmic archaeologists, observing the erosion of a great monument. This is a more melancholic but equally profound possibility. The star would be a tombstone, a silent memorial to a forgotten intelligence, a reminder that even the greatest works of civilizations are not eternal, and will eventually succumb to the inexorable laws of entropy and decay. The sheer number of stars in the Kepler field, over 150,000 of them monitored continuously for 4 years, provides a statistical context for the anomaly. Out of all those stars, only one KIC 8,462,852 displayed this extreme and bizarre behavior. This makes it a, quote, 1 in 150,000 inches event, at least. This rarity can be interpreted in two ways. For proponents of a natural explanation, it suggests a phenomenon that is the result of an incredibly rare alignment or stellar configuration, a perfect storm of celestial circumstances. For proponents of the artificial hypothesis, it could mean that Type 2 civilizations are exceedingly rare, or that they are only briefly visible during their construction phase. If a swarm takes 1,000 years to build, and a civilization exists for millions of years, the chance of us looking at the right star during that specific 1,000-year window is vanishingly small. We might simply have gotten incredibly lucky. The star's location within the constellation Cygnus is purely a matter of line-of-sight perspective from Earth, but it adds a layer of poetry to the story. Cygnus, the swan, is flying down the plane of the Milky Way galaxy. The Star of Whispers is nestled within the swan's wing, a single, strange feather in its celestial plumage. This region of the sky is dense with stars, gas, and dust, a rich stellar nursery, and a busy thoroughfare of our galaxy. It's a plausible place to find a mature star system. The sheer density of background stars, however, also complicates observations, requiring careful analysis to ensure that no foreground or background object is contaminating the light from our target. Astronomers have painstakingly ruled out such possibilities, confirming that the bizarre signal originates from the star itself or its immediate environment, and not from a chance alignment with some other cosmic object. The mystery is localized, a drama unfolding on a single, distant stage. Let's consider the information content of the signal. While it appears chaotic, some researchers have applied complex analytical tools to the light curve, searching for hidden patterns or mathematical structures. Is there a non-random signal buried in the noise? Could the timing of the dips encode prime numbers or some other hallmark of intelligence? So far, no such message has been found. The signal, to our best analysis, appears to be stochastic or random within its strange parameters. This lack of an obvious message aligns more with the idea of a passive techno-signature rather than a deliberate communication. The civilization is not trying to talk to us. We are simply eavesdropping on the industrial noise of their daily lives, the unavoidable consequence of their star-spanning economy. The message, if there is one, is not in the details of the signal but in its very existence. We are here, and this is the scale on which we operate. The emotional journey of contemplating the Star of Whispers is a descent into profound cosmic awe. It begins with intellectual curiosity, the simple desire to solve a puzzle. But as each conventional solution fails, the mind is forced to expand its conception of the possible. We are led from the familiar realm of planets and comets to the speculative shores of alien megastructures and post-biological intelligence. The process mirrors the evolution of human thought itself, from a geocentric to a heliocentric, and finally to a cosmic perspective. The star serves as a catalyst for this intellectual and philosophical growth. It is a mental exercise of the highest order, forcing us to confront the vastness not only of space and time, but of possibility. It is a humbling experience, a reminder that the universe is under no obligation to conform to the limits of our current understanding or our imagination. One of the most powerful aspects of this mystery is its accessibility. While the detailed analysis requires sophisticated tools and expertise, the core concept is remarkably simple to grasp. A star is flickering in a way we can't explain. This has allowed the public to engage with the mystery in a way that is rare for modern astrophysics. Amateur astronomers, citizen scientists, and curious minds from all walks of life have been drawn into the story, offering their own theories and contributing to the discussion. A crowdfunding campaign was even launched to purchase dedicated telescope time for the star, a testament to the public's fascination. The Star of Whispers has become a shared cosmic campfire, a story we are all watching unfold together. It has democratized the process of cosmic discovery, reminding us that the great questions of our existence belong to everyone, not just the experts in their ivory towers. Imagine the star from a closer perspective. If you were on a spaceship approaching the system, what would you see? You would not see a single bright point of light, but a vast, intricate web of darkness and light. Huge, geometric shapes, some glowing with faint city lights, others utterly black, would drift silently between you and the brilliant F-type star at the center. The scale would be disorienting, the silence unnerving. You would be navigating a forest of artificial objects, each larger than a continent. The system would be a symphony of silent, purposeful motion. It would be a direct, visceral confrontation with the concept of the sublime, something that is beautiful and awe-inspiring, but also terrifying in its sheer scale and power. It would be the ultimate testament to the power of intelligence to impose its order upon the raw chaos of the cosmos, a sight that would forever change your understanding of what is possible. Let's return to the infrared problem, the missing heat, as it is the linchpin of the entire mystery. The laws of thermodynamics state that a Dyson swarm must radiate waste heat. If it is absorbing a significant fraction of the star's visible light, it must re-radiate that energy at a longer, cooler wavelength, typically in the mid-infrared. Our most sensitive infrared space telescopes, like Spitzer and WISE, have stared at the star and found no such excess. This is the single strongest piece of evidence against the megastructure hypothesis. To get around this, proponents have to invoke advanced, speculative physics. Perhaps the civilization is converting the energy to mass, or transmitting it away as focused beams of energy, or operating at such a high level of thermodynamic efficiency that the waste heat is negligible or radiated at frequencies we cannot yet observe. It is a profound scientific cliffhanger. The theory provides a perfect explanation for the visible light data, but seems to be contradicted by the infrared data. Could the answer be something entirely unexpected, a phenomenon that belongs to neither the natural nor the artificial category as we understand them? What if the star is interacting with a feature of space-time itself, like a cosmic string or a remnant from the early universe? Or what if it is passing through a strange, filamentary dark matter nebula that absorbs light in unusual ways? These ideas are on the furthest fringes of theoretical physics, invoking concepts for which we have zero observational evidence. Yet the Star of Whispers is such a profound anomaly that it forces us to place all options on the table, no matter how outlandish they may seem. The truth, when we finally find it, may be stranger than any fiction we could invent. It may require a fundamental revision of our understanding of stellar physics, or astrobiology, or even cosmology itself. The philosophical weight of the Star of Whispers is its capacity to induce what is called the overview effect. Astronauts who see the Earth from space often report a cognitive shift, a profound sense of the interconnectedness of life and the fragility of our planet. The Star of Whispers offers a cosmic version of this effect. It forces us to see our own technological achievements, our cities, our satellites, our entire global civilization, as a tiny, nascent first step on a very long road. It places our own struggles and ambitions in a vast, cosmic context. It is a source of both humility and inspiration. Humility, because it shows us how far we have to go. Inspiration, because it shows us how far it is possible to go. It is a single point of light that reframes our entire understanding of our place in the universe and our potential future within it. And so, we are left where we began, staring into the deep, confronted by a mystery. The Star of Whispers continues its strange, silent dance, its light rising and falling, with no regard for our theories or our expectations. It is a perfect enigma, a cosmic koan that defies easy answers. It may be the key to understanding a new chapter in astrophysics, or it may be the key to understanding that we are not alone. For now, it is enough that it makes us ask the questions. It is enough that it draws our gaze upward, away from our terrestrial concerns, and pushes our imagination to the edge of the universe. The star is a gift, a puzzle box delivered across the light years, waiting for a species curious enough and patient enough to one day finally unlock it. The whispers from Cygnus continue, and for now, all we can do is listen. Could the answer be something entirely unexpected? A phenomenon that belongs to neither the natural nor the artificial category as we understand them? What if the star is interacting with a feature of space-time itself, like a cosmic string, or a remnant from the early universe? Or what if it is passing through a strange, filamentary dark matter nebula that absorbs light in unusual ways? These ideas are on the furthest fringes of theoretical physics, invoking concepts for which we have zero observational evidence. Yet, the Star of Whispers is such a profound anomaly that it forces us to place all options on the table, no matter how outlandish they may seem. The truth, when we finally find it, may be stranger than any fiction we could invent. It may require a fundamental revision of our understanding of stellar physics, or astrobiology, or even cosmology itself. We must now consider the Star of Whispers in the context of one of the most sobering concepts in cosmic philosophy, the Great Filter. This idea posits that somewhere between the origin of life and the emergence of a galaxy-spanning Type 3 civilization, there lies a barrier, a challenge so immense that virtually no species ever surmounts it. This filter could be the emergence of intelligence itself, the development of technology without self-destruction, or some unknown cosmic peril. The profound silence of the universe is often taken as evidence that this filter exists and that it is brutally effective, but the Star of Whispers presents a tantalizing counter-narrative. If it is indeed a megastructure, it is evidence that at least one species has passed through the Great Filter. It would mean that survival and ascension to a Type 2 civilization is not impossible. It would transform the silent void from a graveyard into a space of quiet achievers, suggesting that the challenge is not impossibility, but perhaps extreme rarity. Alternatively, the Star of Whispers could represent the Great Filter itself. What if the construction of a Dyson swarm is a natural, perhaps even inevitable step for any advanced species, but it is also a fatal one? Perhaps the engineering is too complex, the social cohesion required is unsustainable, or the very act of manipulating a star leads to unforeseen, catastrophic consequences. The structure could be a trap, a technological singularity that consumes its creators. In this darker interpretation, we are not looking at a monument to success, but at a warning sign. The reason we don't see a galaxy teeming with Type 2 and 3 civilizations is because the very ambition that drives them to that level is also the seed of their destruction. The flickering light from Cygnus would be the final sputtering embers of a civilization that flew too close to its own sun, a cautionary tale written in shadows across the cosmos. The very act of building a Dyson swarm implies a mastery over logistics that defies human comprehension. Consider the raw materials. To build a swarm with enough surface area to block 20% of a star's light, a civilization would likely need to deconstruct every planet, moon, and asteroid in its solar system. This process of disassembly would require gargantuan machines capable of breaking down entire worlds and transporting trillions upon trillions of tons of matter into precise orbits. This is not merely engineering, it is planetary-scale demolition and celestial choreography. The project would have to be managed over centuries, or, more likely, millennia, requiring a continuity of purpose that transcends generations, governments, and even cultural epochs. It speaks to a species that has achieved a form of social and technological immortality, a civilization so stable and unified that it can undertake a project whose completion its earliest architects will never live to see. This leads us to question the nature of the builders themselves. Are we truly picturing biological beings, fragile creatures of flesh and bone, orchestrating this cosmic ballet? It seems more plausible that such a project would be the work of a successor intelligence. A species that reaches this level of technological maturity may inevitably create artificial general intelligence that far surpasses its own capabilities. The construction of the swarm might be delegated to or initiated by these machine minds, self-replicating, autonomous probes, and construction drones that carry out the grand design with perfect efficiency and without the biological limitations of their creators. The creators themselves might have long since perished or retreated into simulated realities, leaving their mechanical children to complete the work. We may be seeing the handiwork not of an alien people, but of an alien protocol, an ancient piece of software still executing its final magnificent command. The concept of von Neumann probes, or self-replicating spacecraft, adds another fascinating layer to this possibility. An advanced civilization wouldn't need to build the entire swarm itself. It could simply build one master factory, one self-replicating seed, and send it to the star system. This probe would use local materials, asteroids, small moons, to build copies of itself. These copies would then build more copies, and this exponentially growing fleet of machine workers would then collaboratively construct the Dyson swarm. This is the most efficient and logical way to undertake a project of this scale. It also means the original civilization could be anywhere in the galaxy. They might have sent out millions of these seeds to promising star systems, and we are simply witnessing one that has successfully taken root. The star is not their home, but merely one of their countless automated construction sites scattered across the galactic plane. Let us push the limits of natural explanations once more, for science demands we exhaust all possibilities before embracing the extraordinary. Could the star itself be the culprit in a way we have not yet conceived? Imagine if the star has a bizarre, complex magnetic field, far more powerful and twisted than that of our sun. These magnetic field lines could trap and levitate vast clouds of plasma and dust ejected from the star, creating enormous transient coronal structures that orbit and obscure the light. These would not be solid, but would be magnetically confined clouds of material, which could explain the lack of a strong infrared signal, as the dust would be sparsely distributed. They could form and dissipate on unpredictable timescales, explaining the aperiodic dimming. This magnetic levitation model is highly speculative and would require a new understanding of stellar magnetohydrodynamics, but it represents a valiant attempt to find a solution within the known laws of physics, albeit at their most extreme and unobserved edge. Another variant of the naturalistic argument focuses on the possibility of a disintegrating celestial body. What if a large planet or brown dwarf in the system is being actively torn apart by the star's gravity? If this object were in a highly eccentric orbit, it would experience immense tidal forces at its closest approach, shedding vast streams of material. This could create a long, curving tail of debris that would periodically occult the star from our point of view. The asymmetry of the light dips would be naturally explained by the comet-like shape of this debris stream. The main challenge to this theory remains the sheer quantity of material required to produce a 22% dip in brightness. The planet would have to be shedding an impossibly large amount of mass with every orbit, suggesting it would have to be a super-Earth or mini-Neptune that is being destroyed at a catastrophic rate, a process that should, once again, produce a detectable thermal signature from the freshly exposed, heated debris. The arrival of the James Webb Space Telescope, JWST, has opened a new chapter in the study of the Star of Whispers. With its unprecedented sensitivity in the infrared spectrum, JWST is perfectly suited to hunt for the elusive waste heat that a megastructure should produce. It can perform high-precision spectroscopy on the star, not just during its quiet phases, but, with luck, during a dimming event itself. By analyzing the starlight that filters through the obscuring object, JWST could detect the chemical fingerprints of its composition. Would it see the silicates and ices of a natural dust cloud? Or would it find the metallic signatures and complex industrial compounds of an artificial construct? Furthermore, JWST can search for heat radiation at much cooler temperatures and longer wavelengths than ever before, potentially finding the missing infrared glow if the structure is far more efficient and colder than we previously assumed. The data from JWST could be the key that finally unlocks this mystery. The potential results from JWST present a fascinating fork in the road of this cosmic story. If a clear infrared excess is detected, precisely matching the models of a Dyson swarm, it would be the most profound discovery in the history of science. It would elevate the megastructure hypothesis from speculation to a verifiable theory, providing the first tangible evidence of intelligence beyond Earth. Conversely, if JWST confirms the utter lack of any infrared excess with even greater certainty, it would strike a severe, perhaps fatal blow to the Dyson swarm idea in its simplest form. It would force even the most ardent proponents to concede that either the builders are using physics that is completely unknown to us, or that the explanation is, in fact, a natural one, albeit one so strange and new that it has perfectly mimicked the signature of a technological artifact. Either outcome represents a monumental leap in our understanding of the cosmos. Let us contemplate the timescale of galactic life. The Milky Way galaxy is over 13 billion years old. Life on Earth is about 4 billion years old. Our technological civilization is barely a few centuries old. It is entirely plausible that civilizations could have risen, evolved to a Type 2 status, and then fallen into ruin billions of years ago. The Star of Whispers might be an archaeological site. The civilization that built it could be a distant memory, and the structure we see is now an untended, decaying relic. The chaotic light curve could be the result of structural failures, collisions between swarm components, and the slow, gravitational dismantling of the entire edifice. We might be witnessing the universe's most magnificent ruin, a cosmic Ozymandias, its purpose forgotten, its builders turned to dust, a silent testament to the impermanence of even the greatest empires. This perspective infuses the mystery with a sense of cosmic melancholy, a lament for a greatness we can never know. The debate over the long-term, century-scale dimming of the star is a perfect example of science in action. The initial study suggesting the star had faded by 20% since the late 1800s was a bombshell. However, subsequent studies using more refined calibration techniques on the same historical data have produced conflicting results, with some finding no significant long-term dimming at all. This is not a failure of science, but its strength. It is a process of refinement, of challenging results, of improving methods to filter out systematic errors. The truth lies buried in the noisy data of a century of different telescopes and photographic technologies. If the long-term dimming is eventually proven to be real, it remains one of the most powerful arguments for a growing artificial structure. If it is proven to be an artifact of old data, then the mystery contracts to focus solely on the deep, short-term dips, which are themselves a profound puzzle. Consider the implications if the structure is a Matryoshka brain, a computational device of stellar scale. What would such an entity think about? Its cognitive processes would be as far removed from ours as ours are from a single neuron. It might be contemplating the fundamental nature of mathematics, simulating the birth of new universes with different physical laws, or housing the uploaded consciousness of an entire species in a simulated paradise that would last for trillions of subjective years. To such a being, the physical universe might be little more than a power source and a hard drive. It would have no reason to communicate, no desire for exploration, no concept of conquest. Its entire existence would be an internal one, a universe of pure thought. The Star of Whispers would be the physical housing for a god, a silent thinking deity whose mind is a cosmos unto itself, utterly indifferent to the fleeting concerns of biological life in the galaxy outside. The very geometry of the transiting objects is a source of intense speculation. The light curves are not simple blockages. They are complex, multi-layered events. Some researchers have tried to invert the light curve to computationally model the shape of the objects that could produce such a specific shadow. The results are fantastical. Vast, triangular structures, huge, flat disks with intricate patterns of transparency, and swarms of smaller, coordinated objects. While this is purely a modeling exercise, it teases the imagination. It suggests that if we are looking at technology, it is not built to be aerodynamic or to conform to any aesthetic we would recognize. Its form is dictated by pure function, the optimal geometry for collecting starlight, radiating heat, or moving through the system. We are glimpsing the architecture of a truly alien mind, a style guide written in the language of advanced physics and engineering. One must also consider the zoo hypothesis as a potential explanation for the behavior. This idea suggests that advanced alien civilizations are aware of us, but have chosen not to make contact, observing us as if we were animals in a zoo or a nature preserve. They may be hiding their presence to allow our civilization to develop naturally, without interference. The structure around the Star of Whispers could be part of this policy. It might be a massive observational outpost, or its seemingly obvious nature could be a test, a cosmic IQ test, to see if we are clever enough to notice them. Or, more simply, its builders may be entirely unconcerned with hiding from a nascent species like our own. Our detection of their project would be as insignificant to them as a bird noticing the construction of a skyscraper. The sheer difference in scale makes any attempt to apply human social motivations, like hiding or communicating, an exercise in pure anthropocentric folly. The puzzle of the Star of Whispers has forced us to confront the limits of our scientific categories. We have a neat binary, natural and artificial, but what if the universe contains phenomena that blur this line? A sufficiently advanced technology, as Arthur C. Clarke famously noted, is indistinguishable from magic, or in this case, from a bizarre natural phenomenon. A civilization that has mastered physics could create structures that operate on principles that seem to us to be natural laws, but are in fact engineered. Conversely, what if life itself is not a rare accident, but a fundamental property of matter under certain conditions, a natural outcome of cosmic evolution? A Dyson swarm could be seen not as an artificial imposition on the universe, but as a natural, predictable phase in the life cycle of a star system that happens to contain intelligence, just as a planetary nebula is a natural phase in the death of a star. Let's delve into the most mundane, and therefore for some, the most scientifically appealing explanation: interstellar dust. Not a swarm of comets or a protoplanetary disk, but simply a chance alignment. The star could be moving through a particularly dense and clumpy region of the interstellar medium, the thin gas and dust that fills the space between stars. If this cloud is unusually structured, with dense filamentary knots of dust, it could produce the strange dimming we observe as the star drifts through it. This theory has the advantage of not requiring any new physics or alien intelligence. Its main weakness is the incredible coincidence required. The interstellar medium is, on average, extremely diffuse. To find a cloud that is dense enough, clumpy enough, and positioned exactly along our line of sight to this one specific star, out of hundreds of thousands, strains credulity. It replaces the mystery of alien intelligence with the mystery of an almost impossible statistical fluke. The color-dependent dimming, where blue light is blocked more than red light, is a critical clue that many have seized upon. This effect, known as interstellar reddening, is the classic signature of fine dust. The latest, most precise measurements have confirmed that this effect is present, leading many astronomers to conclude that dust, in some form, must be the primary culprit. This has been hailed as a victory for natural explanations. However, the mystery is not so easily vanquished. The problem remains that no known natural model, not comets, not a planetary collision, not a protoplanetary disk, can explain the sheer quantity of this dust and its strange chaotic behavior without also producing a massive infrared glow. The confirmation of dust does not solve the mystery, it merely sharpens it. The question is no longer what is blocking the light, but has become what is the origin and nature of this vast, cold, chaotically orbiting cloud of fine dust. This leads to hybrid models that attempt to bridge the gap. What if the megastructure is not made of solid panels, but is a vast, diffuse cloud of smart dust? Imagine trillions of microscopic self-propelled machines, each one a tiny solar collector and computer that operate as a cohesive swarm. This cloud could reconfigure itself, creating dense knots to block the starlight, and could be engineered to be incredibly efficient, radiating very little waste heat. This would explain both the dust signature, the differential dimming of blue light, and the lack of an infrared signal. It is a concept that merges the artificial and the naturalistic, envisioning a technology that is not a collection of massive objects, but a vast, engineered cloud. It is a deeply alien concept, a form of technology that is more like a mist than a machine, but it elegantly resolves some of the most glaring contradictions in the data we have observed. The profound psychological impact of this ongoing mystery cannot be overstated. It creates a state of sustained cognitive dissonance. The rational mind, trained by centuries of scientific progress, seeks the simplest, most parsimonious explanation, which almost always means a natural one. Yet, the data from the Star of Whispers consistently resists these simple explanations. It stubbornly points towards a solution that feels fantastical and improbable. To contemplate this star is to live on a knife's edge of belief, caught between the familiar world of established physics and the exhilarating, terrifying possibility of something truly new. This tension is a powerful engine for creativity and discovery, but it is also a source of deep, meditative unease. It is the feeling of standing at the shore of a vast ocean, having just seen the footprint of something unimaginable in the sand, and knowing that your world will never be quite the same. The Star of Whispers has become a cultural touchstone, a piece of modern mythology. It has appeared in science fiction stories, in music, and in art, capturing the public imagination in a way few scientific discoveries ever do. It has tapped into a deep, primal human yearning for connection, for wonder, and for evidence that we are part of a larger cosmic story. In a world often dominated by cynicism and mundane concerns, this distant, flickering star provides a portal to the sublime. It reminds us that the universe is still full of profound and beautiful mysteries, that there are still great discoveries to be made, and that the quiet act of looking up at the night sky can sometimes reveal a question that has the power to change everything. It is a story not about answers, but about the enduring power of a perfect question. We must scrutinize the central star itself more closely. Is there any overlooked property of F-type stars that could lead to this behavior? These stars are hotter and more massive than the Sun, and they have a much thinner outer convective zone. This difference in internal structure affects their magnetic activity and stellar wind. It is conceivable, though not supported by current models, that certain F-type stars at a specific point in their evolution could enter a phase of extreme, episodic mass loss. They could be shedding their skin, ejecting shells of gas and dust in a chaotic, unpredictable manner. We would be witnessing the star in a rare, short-lived convulsive state. The challenge for this theory is to explain why this process would be so clumpy and why it would lack the expected thermal signatures of hot gas being expelled. It would require us to write a new chapter in the book of stellar evolution, all to explain the strange behavior of a single, solitary star. Let us return to the idea of a companion object, but not a planet or a brown dwarf. What if the star is part of a binary system with a collapsed object, like a neutron star or a stellar mass black hole, in a very wide and eccentric orbit? Most of the time, this companion would be too far away to have any effect. But if its orbit brings it plunging through the outer regions of the star system, its immense gravity could wreak havoc. It could perturb a distant Oort cloud, sending a deluge of comets toward the inner system. It could even tidally disrupt an outer planet, creating a stream of debris. This destructive flyby model could explain the episodic nature of the events and the source of the obscuring material. The primary objection is that such a companion, particularly if it were accreting any material, should be a source of high-energy X-rays which have not been detected. The companion would have to be perfectly quiet, a ghost in the machine. The search for sibling stars is another avenue of investigation. Stars are born in clusters, and even after they drift apart, They often travel through the galaxy in loose associations called stellar streams. By analyzing the motion and chemical composition of the Star of Whispers, astronomers can try to identify other stars that were born from the same primordial cloud. If these sibling stars could be found, we could study them to see if they exhibit any similar, or even precursor, strange behaviors. If they all appear perfectly normal, it would suggest the anomaly is due to something that happened within the star's own system, rather than an intrinsic property of the star itself. If, however, other siblings show even faint signs of similar variability, it would be a powerful argument that we are seeing a new class of stellar phenomenon, a genetic trait shared by a family of stars whose most extreme expression is found in KIC 8,462,852. The concept of a great silence, the inverse of the Fermi paradox, is also relevant here. Perhaps the universe is not silent, but we are simply deaf. Our technology is designed to detect signals that are similar to our own, radio waves for instance. An extremely advanced civilization may have moved on to communication methods that are completely invisible to us, operating on principles of physics we have yet to discover. Their technology, their techno-signatures might be all around us, but we lack the senses to perceive them. The Star of Whispers might be a rare accidental exception, a case where their technology happens to interact with visible light in a way our primitive telescopes can detect. It might be the equivalent of us noticing a slight change in the wind and not realizing it's the wake of a passing hypersonic vehicle. We are seeing the artifact, but we are completely blind to the true nature and purpose of the technology that created it. The timescale of the events provides a fascinating rhythm. The major dimming events last for several days to a week. They are separated by irregular intervals of weeks, months, or even years. Then there was the long 2-year gap where the star remained relatively quiet, before the dimming events returned with a new, almost semi-periodic pattern. This complex temporality is one of the hardest things to explain with a simple natural model. A swarm of comets, or a debris cloud, should have a more random or a more periodic signature. The evolving, complex rhythm feels more like the signature of a dynamic, managed system. It's like watching the traffic patterns of a distant, unseen city. There's an underlying logic, but it's too complex and driven by too many independent agents for us to easily decipher the master plan. The rhythm of the light is the heartbeat of a system whose inner workings remain a profound and tantalizing enigma. We must also consider the possibility of observational error, not in our instruments but in our interpretation. Are we being fooled by a clever conspiracy of unrelated phenomena? Could there be a variable star perfectly aligned behind the Star of Whispers? Or a cloud of gas in our own solar system drifting through our line of sight? These possibilities have been meticulously investigated and largely ruled out. But the principle of scientific skepticism demands we keep them in mind. The universe is a complex place, and chance alignments do happen. However, to explain the full range of observed phenomena, the deep dips, the asymmetrical shapes, the long-term fading, the color-dependent dimming, with a series of unrelated coincidences would require a chain of improbabilities that is, for many scientists, even more fantastic than the idea of a single, coherent, albeit extraordinary cause. The data's strangeness is its strength. It all points to a single, unified source of the mystery. If the artificial hypothesis is correct, what does this say about the prevalence of habitable planets? The star is an F-type star, which are generally considered less ideal for life than G-type stars like our Sun. They have a shorter lifespan and emit more high-energy ultraviolet radiation. The fact that we might be seeing a super-civilization around such a star could mean one of two things. Either life is far more resilient and can arise in a wider range of environments than we thought, or the civilization is not native to that system. They may have evolved around a more stable, nearby star and then expanded, choosing this brighter, more powerful F-type star as the ideal location for their energy-intensive megastructure. The system might not be a cradle of life, but an industrial park, a prime piece of stellar real estate chosen for its energy output, not its hospitality to biology. The sheer audacity of the megastructure concept forces a re-evaluation of our own future. Currently, our civilization, a type 0.7 on the Kardashev scale, runs primarily on the stored energy of dead plants and the power of the atom. The idea of harnessing the entire output of our sun seems like a distant, almost impossible dream. But the Star of Whispers suggests that for another intelligence, this was not a dream, but a viable engineering project. It serves as a stark benchmark against which we can measure our own progress. It tells us that the resources available in a single star system are sufficient to power a civilization of almost unimaginable complexity. It provides a roadmap, or at least a destination, for our own long-term technological aspirations. It is a vision of what we could one day become, if we can survive our own technological adolescence and learn to work together on a truly planetary and eventually stellar scale. Consider the raw power involved. The total energy output of the Star of Whispers is on the order of 10 to the power of 27 watts. To block 22% of this light means the structure is intercepting and, presumably, utilizing an amount of energy that is more than 100 million times the total energy consumption of our entire global civilization. This is a quantity of power that is difficult to describe with any meaningful analogy. It is enough energy to power our world for billions of years, captured every single second. A civilization wielding this kind of power would be, for all practical purposes, masters of their physical reality. The laws of physics would be not so much constraints as they would be tools, to be used to build, to compute, and to exist on a scale that is, to us, fundamentally divine. We are not just talking about a difference in degree, but a difference in kind. The ultimate legacy of the Star of Whispers may be the way it has forced a collaboration between professional and amateur science. The initial detection was made by citizen scientists in the Planet Hunters project, who manually sifted through the Kepler data that algorithms had discarded as too strange. This synergy of machine processing, professional oversight, and the unparalleled pattern recognition ability of the human eye was essential. It is a testament to the idea that the universe is too vast and too strange to be explored by any single group alone. The mystery has united people across the globe, all focused on this one enigmatic point of light. It is a model for a new kind of science, one that is more open, more collaborative, and more inclusive, harnessing the collective intelligence of our species to tackle the greatest questions the cosmos has to offer. We must address the Great Filter from another angle. Perhaps the filter is not a single event, but a gradual process of attrition. Civilizations may rise and fall like waves on a cosmic ocean, with only a tiny fraction ever reaching the shore of long-term stability. The Star of Whispers could represent a civilization at its absolute zenith, the peak of its power and influence, a brief, shining moment before its inevitable decline. The very act of building the swarm could have exhausted its resources, fractured its society, or unleashed ecological consequences on a system-wide scale. The structure could be both a monument to their greatness and the tombstone that marks their demise. The universe might be filled with the ruins of such failed ascensions, the faint shadows of civilizations that reached for the stars and fell. We may be living in a galactic archaeology site, filled with the ghosts of forgotten empires. The possibility of interstellar archaeology is a tantalizing one. If we could somehow send a probe on the 470-year journey to the star, what would it find? Would it find a thriving stellar metropolis, a silent automated machine mind, or a cold dark ruin? The probe would be a time machine, closing the temporal gap between our observation and the star's present reality. Such a mission is far beyond our current capabilities, but it is not impossible in the long run. It sets a generational goal for humanity, a project for our distant descendants. The Star of Whispers could become a destination, a pilgrimage site for a future, spacefaring humanity, eager to learn the secrets of its elder cosmic neighbors. The mystery provides not just a scientific puzzle for today, but a target for the exploratory ambitions of tomorrow. It is a clear and compelling reason to continue our reach for the stars. Let's reconsider the shape of the swarm. It's unlikely to be a uniform sphere of collectors. A more efficient design would be a Dyson bubble, where the components are statites, solar sails that use the star's light pressure to levitate, rather than orbiting in the traditional sense. This would allow for a much lighter structure, requiring less mass. The components could be repositioned easily, allowing the civilization to manage the energy flow. This model also provides a potential solution to the stability problem, as the components are not bound by gravity in the same way. The chaotic light curve could be the result of this constant repositioning, as the civilization adjusts the sails to meet its energy needs. Like a sailor trimming the sails of a ship to catch the wind, we would be seeing the daily operations of their stellar power grid, the flicker caused by their cosmic-sized light switches. A profound question remains: why this star? Out of the hundreds of billions of stars in our galaxy, why does this particular one, relatively close to us, and in the narrow field of view of the Kepler telescope, exhibit this unique phenomenon? It could be a simple case of the, quote, anthropic principle or observational bias. We see it because it's one of the few we were looking at. But it's also possible that there is a deeper reason. What if the structure is deliberately positioned to be observable from our region of the galaxy? This is not to say it's a message for us, but perhaps it's a beacon, a lighthouse, intended for any emerging technological species in this spiral arm of the Milky Way. It could be a deliberate act of cosmic philanthropy from a long-dead civilization, a welcome to the Galactic Club sign left behind for newcomers to find. A puzzle designed to stimulate our technological and philosophical development. Let's circle back to the central paradox. The visible light data screams megastructure, while the infrared data whispers natural phenomenon. This contradiction is the heart of the matter. Science progresses by resolving such paradoxes. The solution, when it comes, will likely be something that is both elegant and surprising. It will either reveal a new exotic form of natural celestial object that can perfectly mimic a technosignature, or it will confirm the existence of a technology so advanced that it can manage its energy in ways that seemingly violate our thermodynamic expectations. Both possibilities are revolutionary. One would expand our understanding of astrophysics, the other would expand our understanding of life itself. There is no boring answer to the riddle of the Star of Whispers. Whichever way the evidence ultimately falls, the result will be a profound transformation of our cosmic perspective. The very language we use to describe the mystery is fraught with assumptions. We talk of builders, civilizations, cities. These are all projections of our own experience. The intelligence behind the structure, if it exists, may not be a collective of individuals. It could be a single, unitary consciousness, a solipsistic God mind that arose from a technological singularity. It may not have a society, a culture, or any of the attributes we associate with civilization. It may simply be. Its motives would be utterly inscrutable to us, not because they are complex, but because they are rooted in a form of existence we cannot imagine. To ask why it built the swarm might be a meaningless question, like asking the ocean why it has waves. The structure might be a simple, inevitable expression of the entity's fundamental nature, a thought made manifest in the physical world. The search for other, similar stars has become a minor industry within astronomy. Researchers are developing sophisticated machine learning algorithms, training them on the light curve of the Star of Whispers, and then unleashing them on the vast archives of data from Kepler, TESS, and other photometric surveys. They are hunting for fainter, less dramatic, or more periodic versions of the same phenomenon. The discovery of a second or third such object would be a game changer. It would allow for comparative analysis, helping to distinguish between a one-off fluke and a genuine new class of object, whether natural or artificial. The uniqueness of the Star of Whispers is both its most tantalizing and its most frustrating quality. Finding another would transform the anomaly into a population, and in doing so, would bring us a giant leap closer to a definitive answer. We must also consider the possibility that we are fundamentally misinterpreting the light curve. Our minds are hardwired to see patterns and agency, a phenomenon called pareidolia. We see faces in the clouds and canals on Mars. Is it possible that the artificial appearance of the light curve is just a trick of perception? Perhaps a truly random natural process can, by pure chance, produce a signal that appears complex and structured to our pattern-seeking brains. This is the ultimate skeptical position, that there is no deep mystery at all, just a random noise signal that we have imbued with meaning. While this is difficult to disprove, the sheer depth and complexity of the dips make it a very unlikely coincidence. It would be like a random gust of wind sculpting a perfect replica of a cathedral. It's possible, in theory, but not a hypothesis one would bet on. The temporal dimension of the mystery is worth dwelling on. We are watching events that happened 470 years ago. In that time, our own civilization has gone from the Dark Ages to the space age. Imagine the changes that a civilization millions of years more advanced could undergo in that same span of time. The construction we see might be finished. The civilization might have moved on, ascended to another plane of existence, or fallen into dust. The object of our study is a ghost, a historical artifact whose present state is completely unknown. This temporal gulf lends a profound sense of humility and helplessness to our investigation. We are cosmic historians, studying a past we can never visit, a present we can never know, and a future we can only guess at. The light from the star is a message in a bottle, and we can only read the page that has just now washed ashore. If the structure is artificial, it represents an almost unimaginable amount of information. The specific design of the components, their orbits, their functions, it is a library of alien knowledge written in the language of physics and engineering. If we could ever resolve the structure in detail, we could potentially reverse engineer their technology, learning about their material science, their energy systems, their computational abilities. The structure would be a Rosetta Stone of alien science, a gift of knowledge beyond our wildest dreams. This is a powerful, almost seductive motivation for continuing the search. The star might hold not just the answer to "Are we alone?" but also the keys to our own technological future, a blueprint for the next stage of human evolution, left for us to find by a silent, anonymous benefactor. The Star of Whispers serves as a powerful antidote to cosmic apathy. It is easy, in our daily lives, to forget the scale and wonder of the universe. The cosmos can feel distant, cold, and irrelevant. But a mystery like this one shatters that indifference. It reaches across the light years and grabs our attention, forcing us to confront the biggest questions of existence. It reminds us that we live inside a grand and unfolding story, and that there are still fundamental secrets waiting to be discovered. It ignites our innate sense of curiosity and our desire to explore. It is a call to adventure for the mind, an invitation to participate in one of the greatest scientific detective stories of all time. It transforms the night sky from a static backdrop into a dynamic stage where the great dramas of cosmic evolution are still being played out. Let us contemplate the silence. If it is a megastructure, why is it so quiet in the radio spectrum? The dark forest hypothesis, that intelligent life deliberately hides, is one possibility. Another is the estivation hypothesis, which suggests that hyper-advanced civilizations, to maximize their computational output, place themselves in a state of hibernation, running their thought processes at incredibly slow speeds in the cold late universe to take advantage of favorable thermodynamics. They are sleeping, waiting for the cosmos to cool down. We might be seeing the equivalent of a house with the lights on, but nobody is home because they are all asleep, not to awaken for trillions of years. This would explain the silence and the lack of expansion. The most advanced beings in the universe might not be active builders, but patient sleepers, dreaming their way to the end of time. The chemical composition of the star itself has been studied in detail, and it appears to be perfectly normal for a star of its type. There are no strange elements in its spectrum that would suggest it has been polluted by alien industrial processes or that it has ingested a large amount of planetary material. This normalcy is, in itself, a clue. It suggests that whatever is orbiting the star is doing so cleanly, without shedding a significant amount of debris into the star itself. This is another point against the planetary collision model, which would likely have contaminated the star's photosphere with heavy elements. For the megastructure hypothesis, it implies a very high level of engineering precision and waste management. The builders are not just powerful, they are tidy, leaving no trace of their industrial work on the star they are enclosing. What if the object is not a Dyson swarm, but something even more exotic? What if it is a wormhole generator, a massive device designed to stabilize a tear in space-time to allow for instantaneous travel across the galaxy? The immense energy required for such a feat would necessitate a star as a power source. The structure would be the physical housing for a gateway, a stargate. The strange dimming could be caused by the energy fluctuations of the device itself, or by objects transiting through the wormhole's entrance. This is, of course, purely speculative, as it requires physics that is far beyond our own. But it is a possibility that captures the imagination. We might not be looking at a habitat or a power station, but a transportation hub, a grand central station of the cosmos, with the flickering of its light being the only sign of the interstellar traffic passing through. The sheer persistence of the mystery is a testament to its quality. In science, most anomalies are resolved relatively quickly. New data comes in, a better model is proposed, and the puzzle pieces click into place. The Star of Whispers has resisted this for years. Every new piece of data seems to add more complexity rather than providing a simple solution. It has survived an onslaught of scrutiny from thousands of scientists. This resilience suggests that we are dealing with something genuinely new, not just a misunderstanding of existing data. It is a black swan event, an outlier that defies all our existing categories. The longer it remains unexplained, the more likely it becomes that the eventual answer will be something truly revolutionary, something that will force us to redraw the maps of our scientific knowledge. Let's consider the star's rotational speed. It spins quite rapidly, completing a rotation in just under 21 hours. This is common for F-type stars, but it could have implications for the mystery. The rapid rotation could contribute to a powerful and complex magnetic field. It could also affect the stability of any orbiting material, creating complex gravitational resonances. Any theory, whether natural or artificial, must account for the environment created by this rapidly spinning luminous star. For a natural model, it adds another layer of complexity to the dynamics. For an artificial model, it represents another engineering challenge that the builders would have had to solve. Designing structures that could remain stable in a dynamic and powerful gravitational and magnetic environment. The star is not a passive backdrop, but an active participant in the drama unfolding around it. The story of the Star of Whispers is ultimately a story about the process of science itself. It is a story of observation, of hypothesis, of testing, and of debate. It showcases the global, collaborative nature of modern research, with data being shared openly and theories being scrutinized by the entire community. It highlights the crucial interplay between skepticism and imagination. We must be skeptical enough to exhaust every mundane explanation, but imaginative enough to consider the extraordinary when the evidence demands it. The star is a perfect case study in how science confronts the unknown. It is not a straight line to the truth, but a winding, complex path, filled with dead ends, surprising turns, and moments of profound wonder. The destination remains unknown, but the journey itself is expanding our horizons in countless ways. Let us imagine for a moment that the builders are still there and are aware of our fledgling observations. What would they think? They might be amused. Like a human watching ants trying to comprehend a discarded smartphone. They might be indifferent, our existence being too fleeting and insignificant to register. Or they might be intrigued, seeing the first stirrings of curiosity in a young species, a sign that we might one day join the galactic conversation. Our telescopes, pointed at their home, are our first, tentative steps onto the cosmic stage. We are like a child shouting into a vast and ancient forest, not knowing who or what might be listening. The silence that comes back is not necessarily an absence, but could be the patient, quiet observation of an elder, waiting to see what we will do next. The Star of Whispers forces us to adopt a perspective of deep time, to think in terms of millennia and eons, not just years or centuries. Civilizations, like stars and galaxies, are likely subject to life cycles of birth, growth, and decay that play out over immense stretches of time. What we are seeing in Cygnus is a single snapshot, a freeze frame, in a process that may have been going on for millions of years. To truly understand it, we would need to watch the movie, not just look at the poster. This perspective is both humbling and calming. It frees us from the need for an immediate answer, allowing us to appreciate the mystery for what it is. A glimpse into the grand, slow, and majestic processes that shape the universe, including the potential evolution of intelligence itself. In the final analysis, we are left with the light. It is the primary witness, the only messenger to have crossed the vast gulf of space and time that separates us from the Enigma. This light carries a story of order and chaos, of profound dimming and baffling recovery, of a stellar heartbeat that follows no known rhythm. It is a stream of photons, a river of information that we have only begun to decipher. As we continue to watch, to listen to this light, we are participating in one of the most fundamental acts of being intelligent. The act of looking out into the darkness and trying to understand. The Star of Whispers does not yet offer us an answer. Instead, it offers us something far more valuable. A reason to keep looking, a reason to keep wondering, and a profound meditative sense of our own place in the vast, silent, and beautiful cosmic night. Let us consider the signal from the perspective of information theory. The light curve of the Star of Whispers is not just chaotic, it is information-rich. A simple periodic signal, like that of a transiting planet, contains very little information. It is predictable and repetitive. The signal from this star, however, is deeply complex. Its periodicity, the varying shapes and depths of its dips, and its long-term evolution represent a high degree of informational content. If we were to try and write a computer program to perfectly replicate this signal, it would have to be an incredibly complex algorithm. This informational density is, in itself, a clue. Nature often tends towards simplicity and predictable patterns governed by basic laws. The sheer complexity of this stellar broadcast hints at an underlying process that is either a form of natural physics far more intricate than we have ever modeled, or it is the incidental noise of a system with a vast number of independently moving, controlled components. The incidental hum of a machine the size of a solar system. A more exotic, though still natural, possibility that must be considered is gravitational microlensing. This phenomenon occurs when a massive but dark object, such as a rogue black hole or a free-floating planet, passes directly between us and a distant star. The gravity of the foreground object acts like a lens, bending and amplifying the light of the background star, causing a predictable, symmetrical brightening event. Could a similar but more complex lensing event be at play? Perhaps a swarm of smaller black holes, remnants of the early universe, is drifting in front of the star. While theoretically possible, microlensing events are extremely rare and have a very characteristic light curve shape, a smooth, symmetrical rise and fall in brightness. They do not produce the sharp, deep, and asymmetrical dimming events we see here. To explain the Star of Whispers with microlensing would require a lensing object so bizarrely shaped and structured that it is, in itself, as mysterious as the phenomenon it seeks to explain. The enduring strangeness of the Star of Whispers pushes the speculative mind towards the ultimate metaphysical questions, such as the simulation hypothesis. This philosophical proposition suggests that our entire reality is a sophisticated computer simulation created by a more advanced intelligence. In this context, a baffling anomaly like the Star of Whispers could be interpreted as a, quote, glitch in the matrix, a piece of code that is not rendering correctly, or perhaps an object that was not intended to be observed by the simulated inhabitants. It might be a piece of the simulation's underlying architecture accidentally showing through the facade of reality. While this is not a testable scientific theory, it serves as a powerful philosophical tool. It highlights how a single, inexplicable data point can challenge our most fundamental assumptions about the nature of reality, forcing us to question whether the laws of physics are truly fundamental or if they are merely the local rules of the simulated world we inhabit. Every star has a, quote, habitable zone, a narrow orbital band where a planet could possess liquid water and potentially support life as we know it. For a bright, hot F-type star, this zone is further out and wider than it is for our own sun. If a civilization were to build a Dyson swarm, it would have a profound impact on this zone. The swarm itself would cast vast, moving shadows, potentially plunging any habitable zone planets into long, irregular winters. The inner edge of the swarm would become a new artificial habitable zone, with the land being the inner surfaces of the orbiting structures themselves. A civilization that builds such a structure is not just harnessing its star's energy, it is fundamentally redesigning its system's astrobiological potential. It is a declaration that they have moved beyond the need for a planetary cradle, choosing instead to build their own habitat, custom-made and precisely engineered, on a scale that redefines the very concept of a world. We tend to assume that any alien megastructure must have a practical, utilitarian purpose, such as energy collection or computation. But this is a projection of our own current technological priorities. What if the structure has no practical function at all? What if it is a work of art? A civilization that has mastered energy and matter to this degree might have moved beyond concerns of mere survival. Their primary motivation could be aesthetic. The structure could be a grand, kinetic sculpture, a stellar-scale mobile whose shadows and light are designed to create a beautiful, complex pattern for observers within the system, or perhaps for no observer at all, existing simply for the sake of its own creation. The strange light curve we see would not be the noise of industry, but the deliberate composition of a symphony of light and shadow. We would not be observing an engineering project, but looking at the single greatest artwork in the known universe. Let us revisit the ruins hypothesis with a focus on the physics of decay. If we are witnessing the slow disintegration of an ancient megastructure, the light curve would be governed by the chaos of orbital mechanics and material science. Over eons, micrometeorite impacts would slowly erode the surfaces, creating clouds of fine dust which aligns with the observed reddening of the starlight. Gravitational perturbations from any remaining planets would cause the orbits of the swarm components to become unstable, leading to collisions. These impacts would create larger debris fields, causing the deeper, more complex dimming events. The system would be a cascade of failures, a slow, grinding process of entropy reclaiming a great work of order. The aperiodic nature of the dips would be the signature of this chaotic decay. We would be watching a cosmic ballet of destruction, a beautiful but melancholic spectacle of a magnificent creation slowly dissolving back into the void. A crucial question for any astronomical observation is the integrity of the signal. The light from the Star of Whispers has traveled for nearly 15 centuries through the interstellar medium. Could something have happened to it along the way? Could a small, dense, and previously unknown type of nebula have drifted through our line of sight, imposing this strange pattern on the starlight? Astronomers have checked for this by observing the star's immediate neighbors. If there were an intervening cloud, it should affect the light from these nearby stars in a similar way. However, the dozens of stars in the immediate vicinity of our target appear perfectly stable and normal. This provides strong evidence that the phenomenon is local to the Star of Whispers itself. The mystery is not in the space between, but is inextricably linked to the star and its immediate environment. The message, however strange, appears to have arrived intact. Contemplating a Type 2 civilization forces us to ask what the endgame of technology might be. If a Dyson swarm provides a virtually infinite supply of energy and matter, what is the ultimate goal? Is it simple, endless survival? Is it limitless expansion, sending probes to colonize the entire galaxy? Or does the goal become more esoteric? Perhaps the ultimate purpose is knowledge, to use the star's energy to power a computer capable of solving the deepest mysteries of the universe, from the origin of the cosmos to the nature of consciousness. Or perhaps the goal is experiential, to create simulated realities of such richness and complexity that they are indistinguishable from, or even superior to, physical reality. The Star of Whispers may be the physical engine for a civilization whose true existence is no longer in the physical world, but in a boundless internal universe of their own creation. Let us imagine a shepherding mechanism for a natural dust cloud. Suppose there is a vast, diffuse cloud of dust orbiting the star, a remnant of some ancient planetary formation or collision. On its own, this cloud would cause a slight, uniform dimming. But now imagine there is an unseen companion object, a large planet or a brown dwarf, in a tilted eccentric orbit. As this shepherd object plows through the disk, its gravity would sculpt the dust, creating dense clumps, spiral arms, and gaps. These gravitationally herded dust structures would then be the cause of the deep, complex dimming events we observe. This model has the advantage of explaining how a natural dust cloud could have such a complex, non-uniform structure. Its primary challenge is, once again, the thermodynamics. A dust cloud massive enough to cause these dips should be warmed by the star and glow brightly in the infrared, a glow that remains conspicuously absent from our observations. We should take a moment to consider the human dimension of this scientific quest. The astronomers who study this star live in a state of perpetual intellectual tension. They are driven by the profound excitement of being on the brink of a potentially paradigm-shifting discovery. At the same time, they are constrained by the rigorous skepticism that is the bedrock of the scientific method. They must constantly challenge their own pet theories and remain open to all possibilities, no matter how mundane. It is a delicate balance between a wild, imaginative leap and a sober, data-driven analysis. The story of this star is not just about photons and gravity. It is about the human spirit of inquiry, about our collective, passionate, and sometimes frustrating struggle to understand our place in the cosmos. The star is a mystery for our instruments, but it is also a profound challenge for our minds and our scientific character. Could we be observing a star undergoing a phase transition? In physics, a phase transition is a dramatic change in a system's properties, like water freezing into ice. While we have a good understanding of the life cycle of stars, it's possible that there are rare, exotic transitional states that are not predicted by our current models. Perhaps under a unique combination of mass, rotation, and chemical composition, an F-type star can enter a temporary state where its energy transport mechanism radically changes. Instead of a steady glow, it might begin to pulsate in a complex way, or eject matter in strange, structured clouds. This would be an entirely new chapter of stellar physics. The Star of Whispers would be our first example of this new class of object. It would mean the solution is not external, in orbit around the star, but internal, deep within the stellar core itself, a new form of cosmic fire we are witnessing for the very first time. The allocation of scientific resources is a competitive process, and the Star of Whispers presents a unique case. Most large telescope time is awarded to projects with a high probability of producing predictable, publishable results. Studying a single bizarre outlier is a high-risk, high-reward proposition. It took a significant effort from the initial research team to convince their peers that the star was not just an instrumental error, but a genuine astrophysical enigma worthy of the world's most powerful observatories. The public fascination and crowdfunding efforts played a crucial role, demonstrating a broad interest that helped justify the dedication of valuable resources. This highlights a challenge in modern science. How do we balance the systematic, survey-based research that builds our knowledge base with the focused, high-risk exploration of profound anomalies that have the potential to completely revolutionize it? The Star of Whispers is a powerful argument for the importance of making room for the unexplained. A darker and more cinematic possibility is that the structure is a form of prison or quarantine. If a star system contains something incredibly dangerous, a hostile AI, a virulent biological plague, a tear in spacetime, a hyper-advanced civilization might choose to encase the entire system to contain the threat. The megastructure would be a sarcophagus, a monument to a cosmic-scale threat that had to be isolated from the rest of the galaxy. The flickering light could be the result of the containment field struggling, or the activity of the entity trapped within. This is, of course, the realm of pure speculation, but it serves as a powerful thought experiment. It reminds us that if other intelligences exist, their motivations and history may not be peaceful or scholarly. The universe could contain dramas of power and peril on a scale we can barely conceive, and we might be unwittingly observing the wall of a celestial asylum. It is a sobering thought that this incredible anomaly was almost missed entirely. The Kepler mission generated a torrent of data, far too much for humans to analyze alone. The initial computer algorithms were programmed to look for the simple periodic signals of transiting planets. They were specifically designed to filter out and discard strange aperiodic signals like the one from the Star of Whispers, flagging them as probable data errors. It was only because of the Planet Hunters citizen science project, where human volunteers looked at the rejected data, that this star was flagged for further study. The human eye, with its incredible ability for pattern recognition and its curiosity for the unusual, saw a signal where the machine saw only noise. It is a powerful lesson for the age of big data and artificial intelligence. Discovery requires not just processing power, but also intuition, curiosity, and the willingness to look at the things that don't fit the pattern. Let us imagine how ancient cultures might have interpreted this star. Without the tools of modern astrophysics, they would have relied on myth and celestial divination. A star that dims and brightens so erratically would have been seen as a powerful omen. It would not behave like the other fixed stars, nor like the predictable wandering stars, our planets. It would have been a unique category unto itself, a star possessed by a capricious deity or a cosmic demon. Its flickering would have been woven into their mythologies, perhaps as a harbinger of war, famine, or the birth of a king. Astrologers would have ascribed it a powerful and unstable influence. The star would have been a source of immense fear and fascination, a divine mystery that shaped belief systems and guided the course of empires. It is a humbling reminder that our own alien megastructure theory is simply our modern mythology, our best attempt to tell a story that makes sense of a baffling sign in the heavens. The principle of Occam's razor states that the simplest explanation is usually the correct one. But what is the simplest explanation for the Star of Whispers? On one hand, invoking a previously unknown form of alien supertechnology seems like a fantastically complex solution. On the other hand, the natural explanations proposed so far also require immense complexity. They demand us to believe in a 1 in a trillion chance alignment of interstellar dust, or a new type of star that violates our current models, or a planetary system with a bizarre, unprecedented architecture that also happens to be perfectly cold in the infrared. The debate hinges on what we consider to be a more radical departure from simplicity: the existence of another intelligence, or the existence of a form of natural physics that has, until now, remained completely hidden from us. The razor in this case is double-edged, and it is not yet clear which way it will cut. We have considered the builders as technological, but what if they are biological? Science fiction has long imagined vast, space-dwelling life forms. Could the structure around the Star of Whispers be a single living organism? Imagine a creature of silicon or carbon, a cosmic tree whose branches are the size of continents, drawing its energy directly from the star through a form of photosynthesis. Its growth, its movements, its very metabolism could cause the dimming events we observe. It would not be a machine built by a civilization, but the civilization itself, a solitary sentient being the size of a solar system. This blurs the line between a technosignature and a biosignature. It would mean that life can evolve to scales that we have never dreamed of, adapting not just to a planet, but to the cosmic environment of a star itself. The mystery would be one of biology, not engineering. The future of our investigation into this star is a multi-pronged attack. In a short term, continuous monitoring by ground-based and space-based observatories is key. We need to build a longer baseline of data to catch more dimming events and analyze their light with ever-increasing precision. The James Webb Space Telescope will continue to hunt for the faintest thermal signatures. In the long term, astronomers dream of even more powerful tools. The next generation of 30-meter class ground telescopes could provide much higher resolution spectra. A space-based interferometer, a fleet of telescopes flying in formation to create a virtual lens the size of a planet, could one day take a direct picture, a blurry but definitive image of what is orbiting that star. And in the very distant future, there is the dream of an interstellar probe, a messenger sent on a centuries-long voyage to see the truth with its own electronic eyes. The biological concept of Umwelt describes the unique sensory world that each organism inhabits. A bat's Umwelt is a world of echoes. A dog's is a world of smells. Our human Umwelt is dominated by vision and sound. Our scientific instruments are extensions of these senses, allowing us to see in radio waves, X-rays, and infrared. But what if the primary activities of an advanced civilization occur in a dimension we are completely blind to? What if they communicate via modulated gravity waves, or manipulate dark matter, or exist primarily as information in a higher dimensional space? Our entire scientific Umwelt would be unable to perceive them. The flickering of the Star of Whispers might be the one tiny, accidental byproduct of their existence that happens to spill over into our limited sensory domain. It would be like trying to understand a city by analyzing the faint tremor its traffic produces in the ground, while being completely deaf and blind to the city itself. Ultimately, this entire story is a meditation on the nature of light. Light is the hero of our story, the faithful messenger that has traveled across an ocean of space-time for nearly 1,500 years to bring us this tale. Its properties, its speed, its spectrum, its wave-particle duality are the very tools we use to decipher the message. But light is also a cruel narrator. Its finite speed means the story is always out of date, the truth always in the past. It shows, but it does not touch. It tells us that something extraordinary is happening, but it cannot, by itself, tell us why. The entire edifice of our cosmic knowledge is built upon the patient collection and interpretation of these ancient photons. The Star of Whispers is a masterclass in reading this celestial language, a lesson in how much can be inferred from the faintest flicker, and a humbling reminder of how much more remains lost in the darkness between the stars. The idea of a stellar spoiler has been proposed as another naturalistic solution. Imagine a companion star, perhaps a small dim red dwarf, in a very close grazing orbit with the main F-type star. As the two stars orbit each other, the larger star's gravity could be stripping matter from the smaller one. This matter would not fall directly onto the star, but would form a vast, opaque accretion disk around it, with the smaller star periodically passing through this disk, causing complex dimming events. The problem with this model is that such a close binary system would be easily detectable through the radial velocity method, where we see the star wobble as its companion tugs on it. Extensive searches for such a wobble have come up empty. The star appears to be, for all intents and purposes, single. For this theory to work, the companion would have to be of an impossibly low mass, making it more of a superplanet than a star, which brings us back to other, already refuted hypotheses. Let us explore the concept of a galactic ecology. Ecosystems on Earth are complex webs of interaction between different species. What if the galaxy has a similar, albeit much grander, ecology? Civilizations might not exist in isolation. They could be part of a network of trade, communication, or even predation. The structure around the Star of Whispers might not be the work of a single species. It could be a collaborative project, a galactic crossroads, or a United Nations of the cosmos, built by multiple intelligences. Or, in a more sinister twist, it could be a farm, a web, or a trap, built by a predator species to harvest the energy or resources of a star system. This reframes the mystery from a solitary act to a social one, hinting that the silence of the universe might not be an absence of life, but a complex political or ecological landscape whose rules we do not yet understand. The sheer amount of time available for life to evolve in the galaxy makes the Star of Whispers both more plausible and more puzzling. Our star, the Sun, is a relative newcomer. Billions of stars, many of them similar to our own, are billions of years older. This means that civilizations could have arisen and reached a technological level far beyond our own long before the Earth even formed. The galaxy could have been home to countless super-civilizations that have since died out or moved on. This ancient aliens hypothesis suggests that the works of such beings could be common throughout the galaxy. The puzzle, then, is why the Star of Whispers is the only clear candidate we have found. If such structures are the logical endpoint of technological evolution, the sky should be filled with them. Their apparent rarity is a deep mystery in itself, suggesting either that we are profoundly mistaken or that becoming a Type 2 civilization is far more difficult or far less common than our theories would suggest. The star's rapid rotation could be a more significant clue than we have given it credit for. A fast-spinning star has a slight equatorial bulge. This oblate shape creates a more complex gravitational field than that of a perfect sphere. The orbits of objects around such a star would precess or wobble in complicated ways. This could be a key factor in any natural explanation. A cloud of debris that would be stable around a slow rotator might be quickly disrupted and dispersed around a fast rotator, or forced into chaotic short-lived configurations that could produce the observed light curve. For the artificial hypothesis, this oblateness would present a significant, though likely solvable, engineering challenge. The builders would have to account for these complex gravitational effects in the design and station keeping of their swarm. The star's spin is a constant, dynamic presence that shapes every aspect of its local environment. Could the structure be a form of stellar life extension? Stars, like all things, have a finite lifespan. An F-type star will burn through its hydrogen fuel in just a few billion years, much faster than our Sun. A sufficiently advanced civilization, facing the eventual death of their star and the destruction of their solar system, might devise a way to prolong its life. This could involve star lifting, a process of removing the heavier elements that build up in a star's core, replacing them with fresh hydrogen from gas giants or interstellar space. This would effectively refuel the star, extending its stable, main-sequence life for potentially trillions of years. The megastructure we see could be the industrial machinery for this stellar rejuvenation project. It would be the ultimate act of sustainability, a civilization not just living with its star, but actively managing it to ensure its own near-eternal survival. The Star of Whispers has also highlighted the psychological biases that can affect scientific interpretation. There is the bias towards finding what we are looking for, known as confirmation bias. Some researchers, excited by the prospect of finding alien life, may be more inclined to favor the artificial hypothesis. Conversely, there is a bias towards conservatism, a reluctance to accept an extraordinary explanation until all ordinary ones have been definitively ruled out. This can lead some to cling to increasingly improbable natural models. The ideal scientific mindset navigates between these two extremes, guided only by the evidence. The ongoing debate surrounding this star is a healthy, if sometimes contentious, process of the scientific community collectively checking its own biases, ensuring that our desire for a spectacular story does not outpace the rigorous demands of empirical proof. Let us consider the galactic internet hypothesis. A network of Type 2 civilizations might communicate not with radio waves, which are slow and diffuse, but with a network of focused laser beams or even more exotic, faster-than-light methods. The structure around the Star of Whispers could be a major node in this galactic communications grid. It would be a massive transceiver, a repeater station powered by the star, responsible for relaying information across vast interstellar distances. The complex dimming could be a side effect of the power fluctuations required to send and receive these massive packets of information. We would be seeing the flickering of a cosmic data center, a server farm for an entire quadrant of the galaxy. The silence in the radio spectrum would be explained because they are simply using a different, far more efficient communication protocol. The very existence of this mystery is a gift to education. It is a perfect, real-world example to teach the core principles of the scientific method. It can be used to explain concepts in physics, from orbital mechanics to thermodynamics. It can be used to teach critical thinking, the evaluation of evidence, and the difference between correlation and causation. It can be used to discuss philosophy, the nature of life, and our place in the universe. This story is accessible, compelling, and still unfolding, allowing students to engage with a live scientific investigation. The Star of Whispers has become more than just a data point. It is a pedagogical tool, a story that can inspire the next generation of scientists, philosophers, and curious minds to look up at the sky and ask their own profound questions. What if the structure is a form of shield? Not against a hostile enemy, but against the universe itself. The cosmos is filled with dangers: sterilizing gamma-ray bursts, deadly supernova shockwaves, rogue planets careening through the dark. A civilization that wishes to survive for billions of years might decide that the safest course of action is to build a shell around itself. The Dyson Swarm could be a colossal suit of armor for an entire solar system, designed to withstand any conceivable cosmic catastrophe. This would be the ultimate defensive posture, a civilization choosing eternal safety over outward exploration. They would become masters of their own isolated bubble, protected from the violent vicissitudes of the galaxy. Their long-term survival would be virtually guaranteed, but at the cost of severing themselves from the wider cosmos, a price they may have deemed necessary to pay for immortality. The star's name, KIC 8,462,852, comes from the Kepler Input Catalog, a list of stars targeted for exoplanet searches. The criteria for inclusion in this catalog were specific: stars that were bright, relatively quiet, and not too young or too old, making them good candidates for hosting detectable planets. This means the Kepler sample was not a random selection of stars, but was biased towards stars like our Sun and slightly larger F-type stars. The fact that the most mysterious star we've ever found came from this targeted search is interesting. It could mean that these Sun-like systems are indeed the most likely place for strange phenomena, whether natural or artificial, to occur. Or it could simply be a result of the streetlight effect. We found something strange where we were looking most intensely, and the true weirdness of the universe may still lie hidden in the star types and regions we have yet to survey with such precision. Let us explore the fine-tuning of the universe as it relates to this mystery. The physical constants of our cosmos appear to be precisely balanced to allow for the existence of stars, planets, and life. If gravity were slightly stronger, the universe would have collapsed back on itself. If it were slightly weaker, galaxies would never have formed. The Star of Whispers, particularly if it's artificial, could be seen as a second layer of fine-tuning. It would represent intelligence taking the already hospitable laws of physics and further refining them, creating a local environment that is even more perfectly suited for its own existence. It is a transition from a universe that is passively habitable to one that is actively inhabited and engineered. It would be a testament to the power of consciousness to not just exist within the laws of nature, but to leverage those laws to create new, emergent orders of complexity and purpose. We have focused on the dimming, but what about the periods of brightening? The light curve also shows small, occasional increases in the star's brightness. These are harder to explain than the dips. A megastructure should only block light, not create it. One speculative possibility is that some components of the swarm are not just collectors, but mirrors. These massive mirrors could be used to focus starlight for industrial purposes or to illuminate the dark side of orbiting habitats. If one of these mirrors were to accidentally flash in our direction, it would cause a brief, intense brightening, a stellar glint. This would be another piece of evidence for a technological origin, as natural phenomena rarely produce such directed, mirror-like reflections. The star's light curve is a rich tapestry of both shadow and fleeting, brilliant light, each element adding to the depth of the central enigma. The search for technosignatures has traditionally been a passive, listening-based endeavor. The Star of Whispers suggests a more active approach might be possible. While sending a message to the star would be futile, as any reply would take nearly 3,000 years, we could attempt to use the star system itself as a signaling device. By using a high-powered laser, we could, in theory, slightly alter the light curve of our own sun. If we could learn to create an artificial, information-rich transit signal, we could place a message in a bottle in our own star's light, a beacon for any other civilization that might be watching us. This is a fantastically ambitious and distant prospect, but the Star of Whispers inspires such long-term thinking. It has shown us what a powerful technosignature looks like, and in doing so has given us a blueprint for how we might one day create our own. What if the obscuring object is not orbiting the star at all but is in our own solar system? This is the interloper hypothesis. Could a vast, dark and diffuse cloud of primordial material, a remnant from the formation of our solar system, be drifting through the Oort cloud and just happen to be passing in front of this particular star? This would explain why no other stars in the field are affected. To test this, astronomers have looked for a parallax effect. As the Earth moves in its orbit around the Sun, a nearby object should appear to shift its position against the distant background stars. So far, no such parallax has been detected for the obscuring material, which strongly suggests it is very far away, at the same distance as the star itself. The mystery, it seems, cannot be brought home. It remains stubbornly out there in the deep, a distant problem for our distant telescopes. The Star of Whispers can be seen as a cosmic Rorschach test. What we see in its ambiguous shadows often reflects our own hopes, fears, and preconceptions about the universe. The optimist sees a thriving, advanced civilization, a beacon of what humanity could become. The pessimist sees a ruin, a warning of the dangers of technology, or a fortress born of cosmic fear. The scientist sees a fascinating puzzle of physics, a chance to discover a new natural phenomenon. The philosopher sees a challenge to our understanding of reality itself. There is no single, correct interpretation yet, and so we are free to project our own narratives onto the flickering light. The star is a blank canvas, and the stories we paint on it reveal as much about ourselves as they do about the distant object of our study. It is a mirror reflecting our own cosmic imagination. Could the structure be a form of data storage? Information, in its physical form, requires matter and energy. To store an almost infinite amount of data, the history of a species, the contents of every mind, a perfect simulation of their universe would require a computer of astronomical proportions. A Matryoshka brain, powered by a star, is the ultimate hard drive. The flickering of the light could be an artifact of the read/write process, the physical manifestation of the computer's operations. This civilization may have chosen to preserve itself not by sending its people into space, but by converting its entire existence into pure information, creating a perfect eternal archive. They would have achieved a different kind of immortality, not of the body, but of the mind and its memories, stored safely in the heart of a machine that is powered by a captive sun. The collaborative, open-source nature of this investigation is a defining feature. The original Kepler data is publicly available. The papers written about the star are published online, often in preprint archives where anyone can read and critique them. The discussions happen in real time on blogs and social media, not just in the closed confines of academic conferences. This has accelerated the pace of the investigation and allowed for a cross-pollination of ideas from different fields. A computer scientist might have an insight into the signal's complexity that an astrophysicist might miss. an engineer might have a better grasp of the structural possibilities. The Star of Whispers is a problem so strange and multifaceted that it seems to demand this new, more open and collective form of scientific inquiry, a global brain focused on a single, baffling point of light. Let us return to the most basic question. What do we know for certain? We know a star, 470 light-years away, is exhibiting profound, aperiodic dips in its brightness. We know these dips are deep, up to 22%. We know they are often asymmetrical. We know the dimming affects blue light more than red light, suggesting the presence of dust. And we know there is no significant excess of infrared radiation. That is the sum of our certain knowledge. Everything else, the comets, the planets, the megastructures, the new physics, is a hypothesis, a story we tell to try and connect these disparate facts into a coherent narrative. It is a humbling inventory, a reminder of the vast chasm between observation and true understanding. We have the first few pages of a great cosmic mystery novel, but the final chapter remains unwritten, its secrets still held captive by the immense darkness of the void. The Star of Whispers has a unique cultural resonance because it feels both futuristic and ancient. It speaks to our science-fictional dreams of advanced aliens and technological wonders. At the same time, it evokes a more ancient sense of awe and mystery, the feeling our distant ancestors must have had when they looked up at the sky and saw something they could not explain. It bridges the gap between our modern, scientific worldview and a more primal, mythic one. It is a mystery that can be appreciated by a child and a theoretical physicist with equal, though different, levels of wonder. It has injected a dose of pure, unadulterated mystery back into a cosmos that, for some, was becoming a little too well understood. It is a beautiful and necessary reminder that the universe still has the capacity to surprise us in the most profound ways. What if the dimming is not caused by an object passing in front of the star, but by something between us and the star that is absorbing the light? A so-called gravity darkening effect on the star itself can be ruled out by its spectrum. But what about a cloud of dark matter or some other form of non-baryonic matter that interacts with photons in a way we don't understand? This is highly speculative, as our primary definition of dark matter is that it does not interact with light. But our knowledge is incomplete. If there were a filament of some exotic light-absorbing substance drifting through that system, it could potentially explain the dimming without producing any heat. It would be a natural explanation, but one that would require a revolution in our understanding of cosmology and the fundamental constituents of the universe. The star's continued performance keeps the mystery alive. After a period of relative quiet, it began dimming again in 2017 and has had several episodes since. This renewed activity was crucial. It proved that the phenomenon was not a one-off event, but an ongoing, dynamic process. It allowed a worldwide network of astronomers, both professional and amateur, to observe the dips in real time, gathering a wealth of new data across the entire electromagnetic spectrum. This ongoing activity transforms the star from a historical puzzle into a live experiment. We are no longer just analyzing old data. We are active observers of a cosmic event as it unfolds. The star is not a static object of study, but a dynamic and unpredictable performer on a distant stage, and we are the captivated audience, waiting to see what it will do next. Let us consider the social structure of the builders. The construction of a Dyson swarm would be a project of such immense scale and duration that it would likely be impossible for a society of competing, individualistic beings like our own. It would require a hive mind, or a collective consciousness, a society where the good of the whole completely subsumes the will of the individual. The builders might not be people in any sense we would recognize, but more like the cells of a larger organism, each performing its function for the good of the collective. Such a civilization would be capable of a unity of purpose and a patience that is unimaginable to us. They would be the ultimate collectivists, a society that has sacrificed individuality for the sake of immortality and cosmic-scale engineering. The structure would be the ultimate monument to the power of the collective will. The energy source for the civilization before they built the swarm is a fascinating puzzle. A Type 2 civilization harnesses the power of its star, but to get there you must first be a very advanced Type 1 civilization, one that has mastered the energy resources of its home planet. This includes things like large-scale fusion power, It's possible that the civilization that built the structure we see had already exhausted the fusionable materials on its planets, like deuterium and helium-3, and the move to stellar power was the necessary next step to avoid societal collapse. The Dyson swarm would be a response to an energy crisis on a planetary scale. This provides a clear and logical motivation for such a colossal undertaking, rooting the fantastical concept in the very practical and universal need for energy to power a growing technological civilization. The Star of Whispers exists at a perfect intersection of known and unknown. The data is clear and precise, a product of our most advanced scientific instruments. The physics of stars and orbits are well understood. This is the known. The unknown is the cause, the mechanism that links these known principles to produce such a bizarre result. Science thrives in this liminal space. If we knew nothing, we could not even ask the right questions. If we knew everything, there would be no questions left to ask. A mystery like this one is a foothold, a place where we can plant our feet on the solid ground of what we know and reach out into the vast, swirling fog of what we don't. It is the perfect engine for scientific progress, a problem just well-defined enough to be tantalizing and just strange enough to be revolutionary. The media portrayal of this story has often simplified it to aliens or comets, but the reality is far more nuanced and beautiful. There is a whole spectrum of possibilities in between these two extremes. There are new stellar physics, new planetary architectures, new types of nebulae, and technologies so advanced they appear natural. The true story is not a simple binary choice, but a rich landscape of competing ideas, a vibrant scientific debate that pushes the boundaries of multiple fields at once. To appreciate the mystery is to appreciate this complexity. It is to understand that the universe is rarely simple, and the most profound truths are often found not in easy answers but in the detailed, patient, and humble exploration of a great and enduring unknown. The beauty is not in the destination, but in the vast and fascinating territory of the journey itself. Let's consider the star's galactic environment. It lies in the direction of the Cygnus Rift, a large dark nebula that obscures the more distant stars of the Milky Way's spiral arm. This means the star is on the near side of this great cosmic cloud. Could this rift itself play a role? While it is too distant to be the direct cause of the dimming, its presence indicates a region of the galaxy that is rich in the raw materials of star and planet formation, gas and dust. It is a fertile ground. It is plausible that this region would be home to more complex or unusual planetary systems, or that it might be a prime target for a colonizing, starfaring civilization looking for resource-rich environments. The star's location is not just a random address, but a clue to the nature of its cosmic neighborhood, a neighborhood that seems predisposed to the creation of complex and mysterious celestial structures. The very act of measuring the star's light is a form of quantum observation. Each photon that strikes our telescope's detector is a single, discrete event, a quantum of information. The light curve is the statistical accumulation of billions of such events. This quantum nature of light sets a fundamental limit on the precision of our measurements, but it also connects this grand cosmic mystery to the strange and probabilistic world of the very small. The behavior of a star system hundreds of light years away is revealed to us through the laws that govern the subatomic realm. It is a beautiful unification of scales, a reminder that the same fundamental principles underpin the vast emptiness of space, the fiery heart of a star, and the electronic detectors of our most advanced telescopes. The cosmos is a seamless whole, and the mystery of the Star of Whispers is written in a language that is spoken from the quantum to the cosmic. Could the Star of Whispers be a one-time event in human history? The universe is dynamic and ever-changing. The phenomenon causing the dimming, whether natural or artificial, may be temporary. In a few hundred or a few thousand years, it might cease altogether. The dust cloud might disperse, the construction might be completed. The ruin might finally crumble into nothing. Future human civilizations might look at this star and see nothing unusual at all. The mystery would vanish, leaving behind only our historical records as evidence that something strange once happened here. We might be living in a privileged moment, a narrow window of time where we are able to witness this extraordinary celestial performance. This imbues our current investigation with a sense of urgency and profound importance. We are the sole custodians of this mystery, and our observations are a legacy we are creating for a future that may never have the chance to see it for themselves. The emotional arc of this mystery is a journey from confusion to awe. The initial reaction to the data was one of bewilderment. It made no sense. It violated our expectations. But as we have lived with the mystery, as we have explored the vast landscape of possibilities it has opened up, that confusion has slowly transformed into a deep and abiding sense of awe. We are in awe of the complexity of the universe which can produce such a perfect puzzle. We are in awe of the power of the scientific method, which allows us to even begin to investigate it. And we are in awe of the sheer mind-stretching scale of the potential solutions, whether it is a new law of physics or a technology that borders on the divine. The star has taught us that the universe is not just bigger than we imagine, it is bigger than we can imagine. And so, the star continues to whisper its enigmatic story across the void. It hangs in the constellation of the Swan, a persistent question mark embroidered into the fabric of the night. It is a scientific problem, a philosophical catalyst, and a source of deep, meditative calm. It defies our categories, challenges our assumptions, and inspires our imagination. We do not know if its shadows are cast by the random dance of dust or by the deliberate architecture of an intelligence beyond our own. But in the end, the search for the answer is, perhaps, as important as the answer itself. For in searching we are forced to look outward, to confront the scale of the cosmos, and in doing so we are forced to look inward, to confront the limits and the potential of our own understanding. The mystery endures, and our vigil continues. The Star of Whispers has become a focal point for our modern anxieties about the future of intelligence. We are at a cusp in our own development, creating artificial intelligences whose capabilities are beginning to surpass our own. We wonder if our creations will be benevolent, indifferent, or hostile. This distant star system presents us with a potential endgame scenario. If the structure is the work of a biological species, it represents a triumph of social cohesion and long-term planning. If, however, it is the work of a post-biological machine intelligence, it represents a future where we, the creators, have become obsolete, replaced by our more capable progeny. The flickering light is therefore a reflection of our own hopes and fears for the singularity. Are we seeing the magnificent work of a species that has integrated with its technology, or the silent, indifferent monument of a machine that has long since forgotten its organic creators? Let us explore the concept of archaeoacoustics, but applied to the cosmos. When we study ancient sites on Earth, we sometimes try to understand how they would have sounded. The Star of Whispers offers a form of archaeophotometry. We are studying the light patterns of a potentially ancient artifact. But what if the structure is not just a passive object, but a resonant one? What if the star's own stellar seismology, its internal vibrations and sound waves, interacts with the swarm, causing it to resonate in specific ways? The light fluctuations could be a secondary effect of this vast, stellar acoustic interaction. The star would be playing the structure like a musical instrument, and the light curve would be the visual representation of that silent cosmic music. We would be observing not just a structure, but a performance, a symphony played on an instrument the size of a solar system, its melody broadcast as a subtle flicker across the light years. The concept of a Kardashev Type 3 civilization, one that harnesses the energy of an entire galaxy, has always seemed like a distant fantasy. But a Type 2 civilization like the one that might inhabit the Star of Whispers is the necessary stepping stone. How does a civilization make that leap? Does it begin sending self-replicating probes to other stars, slowly converting them into Dyson swarms one by one? Does it learn to harness the energy of the galactic core itself? The star system we are observing might not be a home, but a forward operating base, the first step in a project of galactic-scale engineering. The builders might be a young Type 2 civilization, just beginning their journey to galactic mastery. We would be witnessing the birth of a galactic empire, the first brushstrokes of a masterpiece that will one day encompass billions of stars, its ambition written in the language of stellar engineering. The materials required for a Dyson swarm would be immense, but a solar system is a vast repository of resources. The rocky planets provide silicates and metals. The gas giants provide almost limitless quantities of hydrogen and helium, useful for fusion power and as reaction mass. The asteroid belts and Oort cloud provide water ice and carbon compounds. A Type 2 civilization would be master miners, capable of disassembling entire worlds with ruthless efficiency. They would view a solar system not as a collection of beautiful, unique worlds, but as a set of raw materials, a cosmic quarry from which to build their habitat and fuel their growth. This perspective is both awe-inspiring and terrifying. It represents a level of unsentimental, industrial power that redefines the relationship between life and its environment, transforming a planetary system from a home into a resource to be consumed. We must contemplate the ethics of such a civilization. What is the moral framework of a being or a society that can dismantle planets? Do they have a concept of environmentalism on a cosmic scale? Do they preserve some worlds for their beauty or sentimental value? Or is everything subservient to the grand project? If they were to encounter a system with nascent life like our own, what would their protocol be? Would they leave it untouched, following a, quote, prime directive of non-interference? Or would they view it as a minor inconvenience, a patch of mold to be sterilized before the real work can begin? The silence from the Star of Whispers is unnerving because it is ambiguous. It could be the silence of a respectful observer, or the silence of a being so powerful that our opinions are utterly irrelevant to its plans. The star's galactic coordinates place it almost directly in the plane of the Milky Way. This location is a double-edged sword for observation. It means the star is in a dense, active region of the galaxy, a plausible place for advanced life to arise. However, it also means our view is cluttered. There is a great deal of foreground and background dust and gas between us and the star, which complicates our measurements and could, in theory, be responsible for some of the observed phenomena. Astronomers have worked diligently to rule out these galactic cirrus clouds as the primary cause. But the possibility of some strange, localized cloud perfectly aligned with the star can never be completely eliminated. The star's location is both a blessing and a curse, placing it in a region of high probability but also high ambiguity, deepening the layers of the mystery we are trying to solve. Let us speculate on the sensory experience of an inhabitant of such a megastructure. Their sky would not be a single sun, but a vast, intricate lacework of other orbiting habitats and collectors. The light would not be constant, but would be a complex, shifting pattern of light and shadow as different parts of the swarm moved. The concept of day and night would be entirely artificial, controlled by the positioning of their habitat. They might live on the inner surface of a vast cylinder, with the star appearing as a brilliant line of light running down its center. Their connection to the outside universe, the familiar star-filled night sky that has inspired us for millennia, would be gone, replaced by the magnificent but enclosed vista of their own creation. It would be a profoundly different relationship with the cosmos, one of intimate, engineered control rather than distant, passive wonder. The Star of Whispers may be providing us with a solution to the doomsday argument, a probabilistic argument that suggests humanity is likely to go extinct soon. The argument, in simple terms, states that if there were to be a vast number of future humans, it is statistically unlikely that we would find ourselves so early in the total timeline of our species. The existence of a potential Type 2 civilization, which must have survived for eons, would serve as powerful counter-evidence. It would show that a long future is possible for a technological species. It would break the pessimistic probabilistic chain. The star's flickering light would be a beacon of hope, a testament to the fact that the Great Filter is not insurmountable, and that a species can, with sufficient wisdom and technological prowess, navigate the existential risks of its own development and achieve a future that lasts for geological and even astronomical timescales. Let's consider the star's light as a carrier of more than just energy. Could it be used to transmit power? A sufficiently advanced civilization might have developed technology to convert matter directly into energy and then beam that energy across space using focused lasers. The megastructure might be a galactic power station, collecting the star's energy and beaming it to colonies or clients in other star systems. The dimming events could be the result of these massive power beaming events, where a huge amount of the star's energy is being redirected, causing a temporary drop in its apparent luminosity from our perspective. This would also neatly solve the missing heat problem, as the energy is not being radiated locally as waste heat, but is being exported from the system entirely. We would be seeing the operation of a galactic utility company, its business conducted on a scale that beggars the imagination. The mystery of the Star of Whispers has had a profound impact on the field of astrobiology, the study of life in the universe. For a long time, astrobiology was focused on finding life as we know it, microbes, simple organisms, planets with liquid water. This star has forced the field to think more broadly, to consider life as we don't know it. It has popularized the search for technosignatures as a valid and important companion to the search for biosignatures. It suggests that the most detectable evidence of life in the galaxy might not be the faint chemical traces of microbes, but the colossal engineering projects of supercivilizations. It has shifted our focus from looking for planets that look like Earth to looking for stars that look like they've been tampered with, a paradigm shift that has opened up a vast new search space in our quest to find our place in the cosmos. What if the structure is a galactic archive, a library of Alexandria for the entire Milky Way? A civilization that foresees some galaxy-wide catastrophe, like the eventual exhaustion of free-burning stars or a change in the laws of physics, might embark on a project to preserve the knowledge of all life. They would build a massive, shielded, self-powered computer and task it with storing the full biological and cultural information of every species they could find. The structure around the Star of Whispers would be the ultimate preservation project. It would not be a home for a living civilization, but a seed bank, a data vault containing the blueprints of 1 billion extinct species, waiting for a time when the galaxy might be reseeded. The flickering light could be the machine's maintenance cycles, its systems working to preserve the memory of a galaxy that once was, a silent Noah's Ark for the souls of 1 trillion beings. Let us explore the fringe concept of solid light, or electromagnetic solids. Could a civilization with complete mastery over the electromagnetic force create structures made not of matter, but of pure, self-sustaining fields? These would be objects with shape and form, capable of blocking light, but made of nothing more than trapped photons and magnetic fields. Such a structure would be incredibly lightweight, easily reconfigurable, and could potentially explain the lack of a thermal signature, as it is not made of conventional matter that would heat up. This is a concept from the deepest realms of theoretical physics, but the Star of Whispers forces us to consider such possibilities. If we are seeing a technology, it is likely based on principles of physics that are as far beyond our understanding as quantum mechanics would be to a Roman centurion. The building blocks of their world may not be atoms, but the fundamental forces themselves. The star itself is a star of type F. This seemingly dry classification holds a poetic resonance. F is for fire, and this star is a hotter, more brilliant fire than our own sun. But F is also for fleeting. The lifespan of an F-type star is only 2 to 3 billion years. A civilization born around such a star would live with a cosmic deadline. They would know, from the moment they first understood stellar evolution, that their world had an expiration date. This knowledge would undoubtedly shape their entire philosophy and technological drive. The urgency to escape their planetary cradle, to secure a long-term energy source, to achieve a form of immortality would be far greater than it is for a species like ours, born under the gentle, long-lived glow of a G-type star. The megastructure could be a direct response to this cosmic mortality, a desperate, magnificent attempt to out-engineer the death of their own sun. What if the structure is not a single swarm, but the result of 2 warring technologies? Imagine 2 different forms of post-biological intelligence, 2 AIs with conflicting goals, fighting for control of the star system. One might be building a traditional Dyson swarm, while the other is attempting to dismantle it or build a different kind of structure. The chaotic light curve would be the result of this ongoing, silent war. The dips and flickers would be the visible evidence of battles, of construction and deconstruction, of attacks and repairs, all happening on a scale and at a speed that we can only perceive as a strange, random pattern of light. We would be unwitting spectators to a conflict between machine gods, a war in heaven whose nature and stakes are completely beyond our comprehension. The star system would not be a home, but a battlefield. Let's consider the role of gravity. The structure, if it exists, would have its own gravitational field. The total mass of a Dyson swarm could be equivalent to a large planet. This mass would be distributed in a complex, shifting shell, The gravitational dynamics of such a system would be incredibly complex. It would create strange resonances and stable points, but it would also be inherently unstable without active management. Could the dimming events be caused by gravitational lensing from the swarm's own components? As a particularly massive habitat or collector passes in front of the star, its own gravity could be subtly bending the starlight in ways that contribute to the complex shape of the light curve. The shadow we see would be a combination of the physical blockage and the subtle gravitational warping of space-time caused by the object itself, a hybrid signature of both matter and gravity. The Star of Whispers can be viewed as a profound lesson in cosmic humility. For most of our history, we have placed ourselves at the center of the universe, first physically, then biologically, and finally, intellectually. We have acted as if we are the sole proprietors of consciousness and meaning. This single point of light challenges that final vestige of our cosmic arrogance. It suggests that we may be, at best, a typical developing intelligence, and at worst, a cosmic backwater, utterly insignificant on the grand scale of galactic life. This is not a pessimistic view, but a liberating one. It frees us from the burden of being the only mind in the cosmos. It allows us to see ourselves as part of a much larger, and likely much older, story. It is a coming-of-age moment for our species, the moment we realize that we are not the protagonists of the story, but perhaps just minor characters in a single chapter of a vast cosmic epic. What if the structure is not designed to absorb energy, but to emit it in a specific form? Consider a stellar beacon. A civilization might want to create a landmark, a lighthouse, that is visible across intergalactic distances. To do this, they could build a structure around their star that modulates its light, causing it to pulse with a specific, artificial signal, a cosmic Morse code. The Star of Whispers would be just such a beacon, and its strange aperiodic signal might be a complex message that we simply lack the key to decipher. Why would they do this? Perhaps to attract the attention of other civilizations, or to mark a specific location in the galaxy, or as a memorial to their own existence. The purpose would be communication, but not a conversation. It would be a monologue, a single, powerful statement broadcast into the void for eons, a message in a bottle waiting for someone, anyone, to find. The timeline of the discovery is itself a story of serendipity. The Kepler telescope was not designed to find alien megastructures. It was looking for Earth-sized planets. It stared at one small patch of the sky for 4 years, a tiny keyhole through which we viewed the cosmos. And in that one tiny patch, it found this incredible anomaly. What are the odds? It suggests that either we got phenomenally lucky, or that such objects, or the natural mimics of them, are far more common than we think, and the sky is littered with them, waiting to be found. Now that we know what to look for, new surveys like TESS are scanning the entire sky. The legacy of the Star of Whispers may be the discovery of dozens or even hundreds of similar weird stars, transforming a single mystery into a whole new field of astronomical inquiry, the study of stellar-scale macro-phenomena. Let us explore the psychological state of a civilization that builds such a thing. They would need to possess a form of deep patience that is alien to our own fast-paced culture. The project would take millennia. Generations would be born, live their entire lives, and die, all while working on a single vast project whose completion they would never see. This requires a profound connection to the past and a powerful sense of obligation to the future. Their culture would have to be incredibly stable, their values centered on legacy, continuity, and the grand, slow unfolding of their cosmic destiny. They would be the ultimate cathedral builders. But their cathedral is a solar system, their stained glass is the filtered light of their sun, and their timescale is not measured in centuries, but in the long, patient, silent turning of the stars. The Star of Whispers may be the ultimate wow signal. In 1977, a SETI project detected a strong, narrow-band radio signal that lasted for 72 seconds and then was never heard from again. It was nicknamed the wow signal for the exclamation its discoverer wrote on the printout. It remains a profound, unsolved mystery. The Star of Whispers is a different kind of signal. It is not a brief, transient whisper, but a continuous, roaring enigma. It is not in the radio spectrum, but in the most basic, fundamental property of a star, its light. It is a wow signal not because of its strength, but because of its sheer, blatant, and persistent weirdness. It is a constant presence, a mystery that does not fade away, but patiently waits for us to develop the science and the imagination required to finally understand its meaning. The story of this star has permeated our culture, becoming a new myth for a scientific age. It represents the frontier, the place where the map of our knowledge ends and the wild, untamed territory of the imagination begins. Artists paint their interpretations of the megastructure, musicians compose soundscapes inspired by the light curve, and writers craft stories about the lives of the builders. This process is not just entertainment, it is a vital part of how we, as a culture, process a profound scientific mystery. Art and storytelling allow us to explore the emotional and philosophical implications of the data, to ask what if in a way that science alone cannot. The star has become a shared dream, a collective thought experiment that pushes not just the boundaries of our science, but the boundaries of our art and our humanity as well. Let us consider the name KIC 8,462,852 inches one last time. It is a name born of data, a coordinate in a vast catalog. It is cold, impersonal, and precise, yet this sterile designation has become attached to one of the most romantic and awe-inspiring mysteries of our time. This contrast is beautiful. It shows that wonder is not the opposite of science, but its ultimate reward. We begin with the cold, hard data, with the meticulous, dispassionate analysis. We follow the numbers, we check our biases, we adhere to the rigor of the method. And if we are patient and diligent, the data can lead us to a place of profound, almost spiritual awe. The journey through the sterile landscape of data can deliver us to the shores of the sublime. The star's technical name is a reminder that the path to wonder is paved with rigor. The mystery forces us to confront our own cosmic insignificance in a new way. It's one thing to know that the universe is vast and we are small. It's another thing entirely to have tangible, observational evidence of a power that so completely dwarfs our own. The potential civilization at this star is not just a little more advanced than us. It is to us as we are to a single-celled organism. This realization can be terrifying, but it can also be profoundly calming. It means that the fate of the universe does not rest on our shoulders. We are not the sole bearers of the flame of consciousness. We are part of a much larger and likely much more competent cosmic community. We are free to pursue our own development, to solve our own problems, without the existential weight of being the only meaningful thing in an empty cosmos. It is the liberation of insignificance. What if the structure is a form of galactic-scale agriculture? A civilization might not be harvesting energy, but specific, rare elements created within the star's core. They could be using advanced star lifting technology to carefully extract these elements without disrupting the star's overall stability. The structure would be a fusion of a mine, a refinery, and a transportation network. The dimming events could be caused by the periodic operation of these massive stellar dredges, casting shadows as they maneuver into position. This frames a civilization not as thinkers or artists, but as farmers or miners, tending to their star to harvest its unique bounty. It is a more practical industrial vision of a Type II civilization, one driven by the universal need for specific resources that can only be forged in the heart of a sun. The Star of Whispers is a perfect illustration of the edge of chaos, a concept from complexity theory. The edge of chaos is the fertile zone between perfect order and complete randomness, where complex, adaptive systems can emerge. A signal that is perfectly ordered, like a sine wave, is boring. A signal that is pure white noise is meaningless. The light curve of this star lies in that sweet spot in between. It is structured but not predictable. It is chaotic but not completely random. It has the signature of a complex system. This is why it is so compelling. It feels alive. Whether it is the complexity of a new form of stellar physics or the complexity of a bustling, alien economy, we are observing a system that is operating at this creative, dynamic edge, a system that is rich with information and pregnant with possibility. The silence of the universe, the Fermi paradox, may be a matter of mismatched timescales. Imagine a galactic history spanning 10 billion years. Civilizations might rise, flourish for 1 million years, and then vanish. The galaxy could have been home to thousands of such civilizations, but they were spread out so far in time that no two ever existed at the same moment. The galaxy would be like a dark room where people are lighting matches. The room has been full of light over the eons, but at any given instant, it appears dark. The Star of Whispers could be one of these fleeting match strikes. We happen to be alive at the exact right moment to see its light. The reason the sky is not filled with them is that their lifespan, while long to us, is a mere flicker in the vastness of cosmic time. We are witnessing a rare and beautiful moment of transient, cosmic illumination. The mystery has also shown us the power of a single, unifying question. In a world that is often divided by politics, culture, and belief, the riddle of this star has brought people together from all over the globe. Scientists from dozens of countries are collaborating on the research. Citizen scientists from all walks of life have contributed to the observations. It is a shared human endeavor. It reminds us that at our core, we are a curious species, driven by a desire to understand the universe we inhabit. A great mystery has the power to transcend our petty differences and unite us in a common sense of wonder. The star is a gift that has allowed us, for a moment, to look up at the same point in the sky and feel a shared sense of awe and a common purpose. Let us contemplate a final, profoundly simple, natural explanation. What if the star is simply a normal F-type star, and it is orbited by a single, gigantic and bizarrely shaped object? Not a swarm, but one object. Imagine a planet that has been shattered by an impact, but the pieces have not dispersed. Instead, they are held together by some strange, tar-like organic chemistry, forming a vast, irregular clump of rubble. Or imagine a single, ring-like structure of dust held in a stable but tilted orbit. These single object models are less popular because it is difficult to explain how such a structure could form and remain stable, but they represent an attempt to find a solution that is both natural and singular, avoiding the complexities of a swarm. The universe has surprised us before with the strange shapes and configurations of its celestial bodies. Perhaps the Star of Whispers is simply the strangest one we have yet found. The journey of discovery is often not a eureka moment, but a slow, gradual dawning of understanding. We may never find a single smoking gun that solves the mystery of the Star of Whispers. Instead, the answer may emerge slowly, over years or decades, as we gather more data, refine our models, and eliminate possibilities one by one. The truth may not be a sudden revelation, but a subtle shift in the balance of probabilities, as one explanation gradually becomes more plausible and the others fall away. This is the patient, diligent reality of scientific work. It is less like a lightning strike and more like the slow, inexorable erosion of a stone by a river. The river of data continues to flow, and in time, it will wear away the rock of our ignorance and reveal the true shape of the landscape beneath. The Star of Whispers has taught us that the universe is under no obligation to be simple or to make sense on our terms. We have a tendency to want neat, tidy explanations that fit within our existing worldview. But the cosmos is vast and ancient, and it has had far more time and space to generate novelty than we have had to observe it. It is entirely possible that the explanation for this star is something that is currently unimaginable to us, something that will require a revolution in our understanding of physics or biology or intelligence. The star is a lesson in intellectual humility. It is a reminder that our knowledge is a small island in a vast ocean of mystery, and the most exciting discoveries are likely to be found not on our familiar shores, but far out in the uncharted waters of the unknown. We are a species defined by our relationship with mystery. Since the dawn of consciousness, we have looked up at the night sky and wondered. We have told stories, created myths, and eventually developed science to try and make sense of the vast, silent darkness. Mystery is the engine of our curiosity, the fuel for our imagination, the catalyst for our intellectual growth. A universe without mystery would be a sterile place, a solved equation, with no room for discovery. The Star of Whispers is a gift, a perfect, exquisite mystery delivered to our doorstep. Its value lies not in its eventual solution, but in its current, profound, and beautiful insolubility. It is a challenge, an invitation, and a promise that the universe is still a place of wonder, a place where there are still great dragons on the map to be found. Contemplating this star is a form of meditation. It allows the mind to detach from the immediate terrestrial concerns of our daily lives and to expand into a cosmic perspective. To think about the scale of the star, the distance of the light, the immensity of the potential structure, is to engage in an exercise that stretches the very fabric of our consciousness. It is a calming practice, as our own problems and anxieties shrink into insignificance against the vast backdrop of stellar evolution and cosmic engineering. The star is an anchor for the mind, a single point of focus that can lead to a state of profound tranquility and intellectual awe. It is a reminder that we are part of something indescribably vast and beautiful, and that there is a deep peace to be found in the silent, patient contemplation of the great unfolding mystery of it all. The absence of an answer is not a failure. It is a space of possibility. As long as the mystery remains unsolved, it is a canvas upon which we can project our grandest ideas. It is a realm where the physicist, the philosopher, the artist, and the dreamer can meet and converse. The moment a definitive answer is found, this space will collapse. A single fact will replace 1,000 beautiful theories. And while that fact will be a triumph for science, something precious will be lost: the shared, collective sense of wonder that the mystery currently provides. And so, we should cherish this period of not knowing. We should celebrate the ambiguity. It is a rare and fertile moment in the history of thought, a time when a single point of light can contain the infinite possibilities of the entire cosmos. Let us zoom out to the scale of the galaxy itself. The Milky Way is a swirling city of 200 billion stars. Our sun is but one citizen in a quiet, suburban spiral arm. The Star of Whispers is another, in a slightly busier neighborhood. From this perspective, it is almost inevitable that some of these stars would have bizarre, unique properties. It is almost inevitable that if life is common, some of it would have evolved to a level that can manipulate its environment on a stellar scale. In a galaxy this large and this old, the truly surprising thing would be if we found nothing strange at all. The Star of Whispers is not an anomaly that breaks the rules of the cosmos. It is a confirmation of the ultimate rule, that in a universe of this size, anything that is not forbidden by the laws of physics is, somewhere at some time, mandatory. The light from the Star of Whispers that reaches our telescopes tonight began its journey in the middle of the 6th century. It has been traveling through the silent, cold emptiness of interstellar space ever since, a lonely stream of photons carrying a secret. It has passed through nebulae, dodged dust clouds, and journeyed for 15 centuries, all to end its existence by striking a detector on a small, human-made satellite orbiting a pale blue dot. There is a profound poetry in this journey. It is a story of immense distance and incredible precision, a connection across a gulf of time and space that is almost too vast to comprehend. We are the endpoint of that ancient light, the final witnesses to its long pilgrimage. Our duty is simply to observe, to listen, and to be worthy of the incredible story it has traveled so far to tell us. What if the structure we see is not the main event, but a byproduct? A civilization that has mastered travel between dimensions or through hyperspace might require a massive energy source to anchor its portals. The star system would be a power plant for a transportation network that is entirely invisible to us. The structure we see would just be the exhaust pipe or the cooling system for a technology whose primary function is in a realm we cannot perceive. This would explain why we see the artifact but not the civilization. Their city is not in our space, but our space is where they have built their power station. We are like islanders who see a geothermal vent on the side of a volcano, unaware that it is powering a vast, underwater city just beyond the reach of their sight. The entire human experience of time is tied to the cycles of our own planet and star, the day, the year. An inhabitant of a Dyson swarm would have no such natural cycles. Time would be a purely artificial construct. Their day could be 100 hours long or 1,000. Their year could be a meaningless concept. They might measure time not by celestial mechanics but by computational cycles or energy consumption. This would lead to a profoundly different consciousness, a mind untethered from the natural rhythms that have shaped every living thing on Earth. Their perception of reality, their art, their philosophy, all would be born from a completely engineered environment. To understand them would require us to shed our most basic, ingrained assumptions about the nature of time and the rhythm of existence. The starlight itself, when we analyze its spectrum, tells us the chemical composition of the star's atmosphere. It is a mix of hydrogen, helium, and trace amounts of heavier elements, which astronomers call metals. The specific ratio of these metals is the star's metallicity, and it tells us about the star's age and origin. The Star of Whispers has a perfectly normal metallicity for a star of its type. This is a subtle but important clue. It means the star is not a strange, exotic object in itself. It is a normal star that is having something strange happen to it. This focuses the mystery squarely on the star's environment, on the objects or clouds that orbit it. The problem is not with the lamp itself, but with the lampshade, a lampshade of a design and material that continues to confound and enchant us. We are at the end of our inquiry, and we are left with more questions than answers. This is not a failure, but the very essence of the scientific and philosophical enterprise. The goal is not always to arrive at a final, comfortable certainty, but to deepen our appreciation of the complexity of the question. The Star of Whispers has done this magnificently. It has forced us to confront the limits of our knowledge, the biases in our thinking, and the vastness of our own cosmic ignorance. It has not given us a new fact so much as it has given us a new and much larger framework for our wonder. The star is a teacher, and its primary lesson is one of humility. It has taught us that the universe is not just a puzzle to be solved, but a mystery to be lived in. And so, the great cosmic silence continues. The Star of Whispers flickers, but it does not speak in a language we can understand. The radio telescopes listen, but they hear only the hiss of the void. We are surrounded by a profound and beautiful quiet. This silence can be interpreted as loneliness, or it can be interpreted as peace. It can be seen as an absence of life, or as the respectful quiet of a universe filled with minds who have chosen contemplation over communication. The truth remains hidden, but as we listen to that silence, as we watch that distant flickering light, we can feel a sense of connection, a shared existence in this vast and mysterious cosmos. We are all, the star, the potential builders, and ourselves, part of the same silent, unfolding story. In the quiet of the night, when you look up at the constellation of Cygnus, you are looking towards the Star of Whispers. It is too faint to be seen with the naked eye, a secret hidden in plain sight, but knowing it is there changes the way you see the sky. It imbues that patch of darkness with a sense of profound mystery and potential. It is a reminder that every point of light in the sky is a sun, a place, a potential history, and that some of those histories may be far stranger and far more magnificent than our philosophy has ever dreamed. The night sky is not a static painting, but a living library of stories, and we have only just learned to read the first page of its most enigmatic book. The darkness between the stars is not emptiness, it is a vast ocean of distance and time. And across that ocean, light travels as a patient, tireless messenger. It carries tales of cosmic birth, of stellar life, and of fiery death. And from one particular star, it carries a story we cannot yet read, a riddle wrapped in a mystery. The light falls upon our world, upon our telescopes, a gentle, silent rain of photons that has traveled for 1,500 years. We collect this ancient light, we analyze it, and we are left in a state of profound and meditative wonder. The need to know fades, and is replaced by a simple, quiet appreciation for the mystery itself. Let your mind drift now, out past the orbit of our moon, beyond the planets of our solar system, into the deep interstellar void. Journey on a beam of light towards that distant star in Cygnus. As you travel, the concerns of our small world fall away. The scale of the cosmos expands to fill your consciousness. You are a silent observer, a traveler in the vast, quiet emptiness. There is no sound here, only the steady, ancient light of a billion suns. There is a deep peace in this immensity, a sense of belonging to a reality that is far grander and more eternal than our fleeting daily lives. You are a part of this cosmic tapestry, a thread of consciousness woven into the fabric of space-time. We float now in the silent theater of the cosmos. The Star of Whispers is just one of countless points of light, each with its own story, its own secrets. The universe does not owe us answers. It does not exist to be understood by us. It simply is. And our role is simply to be within it, to witness its majesty, to feel its scale, and to find a sense of peace in our own small, but not insignificant, part of its grand design. The flickering of that distant star is a cosmic heartbeat, a rhythm that is both baffling and beautiful. And as we watch it, we can feel our own heartbeats slow, our minds calm, and our spirits settle into a state of deep, cosmic repose. The search for knowledge gives way to the acceptance of mystery. The desire for answers dissolves into a state of pure awe. We are small, and the universe is vast. And in that simple, profound truth, there is a great and abiding comfort. The star will continue to flicker, the light will continue to travel, and the mystery will continue to endure, long after we have drifted off into our own quiet internal darkness. The story will be there for us when we awaken, but for now, it is enough to simply float in the silent, star-dusted sea of the unknown, and to let the gentle, cosmic tide carry us into a state of deep and dreamless sleep. The grand narrative of the cosmos is written in light and gravity, in time and space. We are but brief readers of this epic text, catching a glimpse of a single, puzzling sentence on a page in the middle of the book. We do not know what came before, and we cannot know what will come after. Our part is to simply appreciate the beauty of the prose, the elegance of the language, and the profound depth of the mystery it presents. The Star of Whispers is a perfect poem, one that means more for the questions it raises than for any answer it might one day provide. It is a lullaby sung by the universe itself, a quiet, flickering song to soothe the restless mind. The silence of space is not an absence, but a presence. It is the canvas upon which the light of stars is painted. It is the vast, resonant chamber in which the slow dance of galaxies unfolds. In our noisy world, we have forgotten the power and beauty of silence. The Star of Whispers invites us to return to it, to listen not for a signal, but to the quiet itself. To find in the vast, silent darkness a sense of connection to the fundamental reality of the cosmos. It is a silence that holds all possibilities, all stories, and all futures. It is a silence that is deep, ancient, and profoundly peaceful. As we drift towards sleep, we can let go of the need to solve the riddle. The mystery is not a problem to be fixed, but a state to be inhabited. We can wrap ourselves in the comfortable cloak of not knowing, and find rest in the vast, open-ended nature of the question. The universe is under no obligation to be simple. It is complex, and strange, and beautiful. And so are we. We are the part of the universe that has woken up for a brief moment to ask why. The answer, for now, is the quiet hum of the cosmos, the gentle turning of the spheres, and the silent, patient flicker of a single enigmatic and deeply peaceful star. The journey is complete. We have traveled from a single, baffling data point to the furthest reaches of speculation. We have weighed the comets against the megastructures, the natural against the artificial, the known against the unknown. And we are left here, in a place of quiet wonder. The star remains, a distant campfire in the cosmic night, telling a story we are only just beginning to learn how to hear. Its light will continue to fall upon our world, a steady, gentle reminder of the immense and beautiful mystery that surrounds us. Let that light be a beacon that guides you into a state of deep calm, a focal point for the mind as it prepares for its own nightly journey into the silent, internal cosmos of dreams. The whispers from Cygnus fade into the deeper silence of the void. The need for explanation dissolves. The mind grows still. All that remains is the vast, dark, and gentle presence of the night. The stars turn, the galaxies drift, and the universe continues its slow, majestic, and silent breathing. You are a part of this breath, a part of this silence, a part of this night. There are no more questions. There are no more answers. There is only the deep, profound, and peaceful emptiness. The star has done its work, and now there is only rest.